सो वेलकम ऑल, गुड आफ्टरनून। कैसे आप सब लोग? गुड आफ्टरनून, ठीक है। सो होप योर एमए एग्जाम हैव गॉन वेल एंड नॉर्मली सिंस एमए हैज़ ऑलरेडी डन, ओके, मैंने आपसे एक चीज़ क्लियर करना चाहता हूँ कि लाइक एक्सी इज अगेन वन वेरी इंपॉर्टेंट ऑप्शन इफ sole target is going to MTech at IITs or IISc and places. Yeah, okay. So if you see, if you take any IIT, okay, or like in IISc maybe, if you take the number of students in a class, like for example mechanical या किसी और branch में, like 50% of the, more than 50 in fact, if you see, if you count the ground reality, those admissions are based on XE. Okay, so this option of writing gate in XE is like a very good option in case by some source, because of some reason, if your ME exam didn't go fine. Okay, so पहले मैं इस सेशन में कुछ चीज़ क्लियर करना चाहता हूँ, ठीक है। सो वी हैव ब्रॉट अप इस सेशंस फॉर सीरीज ऑफ PYQs टू बी सॉल्व, क्योंकि हम नॉर्मली एक्सी मैथ्स कंपलसरी है। सो कल जो सेशन हुआ था उसमें विनोद सर और अपूर्व सर ने आपको क्लियर कट आइडिया दिया था, मतलब एग्जाम का पैटर्न कैसा होता है। लाइक एप्टीट्यूड एंड मैथ्स आर कंपलसरी सब्जेक्ट्स एंड उसके अलावा बाकी जो सब्जेक्ट्स है उसमें से 2 सब्जेक्ट्स चूज करना पड़ेगा। लाइक नॉर्मली इफ यू आर फ्रॉम द मैकेनिकल बैकग्राउंड और in the similar backgrounds, then you have material science, solid mechanics, fluid mechanics, thermodynamics, these kind of subjects in general. Okay, and इस sessions में हम इस 3 subjects को cover कर सकते हैं. Like for example maths is anyhow compulsory, so we will do, but we will also focus on fluid mechanics, okay, and we'll focus on this solid thermodynamics and also solid mechanics, and of course you know maths is compulsory. So this is a quick schedule of the sessions, okay, which I think yesterday you have come to know of this, but again today I just like to give you quickly. Okay, so today 4th February we are starting with this fluid mechanics XE-B as the first session, and after me Sandeep sir will continue for the next 2 days. And also like today evening, basically we have divided the day into 2 slots, like the 2 to 5 p.m. slot and 7 to 10 p.m. slot actually. Okay, so in the 7 to 10 p.m. slot, for the first 3 days you'll have XE maths, which I myself will take these 3 sessions, and then thermodynamics by Shivam sir and Vinod sir, and solid mechanics by Apurv sir and Ramanand Bansal sir. Okay, and after this PYQ solving, because after writing mechanical exam आपने PYQs का importance recognize किया था, like if you have solved all the PYQs of mechanical at least for the last 10 years, and if you go for GATE 2025, if you have went for GATE 2025, then you would have done very well definitely. Okay, so we initially thought of solving the PYQs, and उसके बाद we'll also have the अभ्यास sessions, okay, क्योंकि नया questions भी practice करना काफी important है। so इसलिए like from last like 10, 11, 12, 13 again we'll focus on the 2 अभ्यास sessions for each subject, like fluid, thermo, maths and solid, or solid and maths, whatever. Okay, solid and maths actually. So this is going to be the complete schedule. Okay, and when I am solving PYQ sessions or अभ्यास sessions or any other time in the Telegram channel, okay, if you have any doubts, okay, और लगता है कि सर इस कॉन्सेप्ट में मुझे इतना क्लैरिटी नहीं है, so this concept is like doubt to majority of the students, लेकिन ये टॉपिक काफ़ी रिपीटिंग है, so if you just want to give me some small glimpse of the topic, I'll give you, no issues. ठीक है, so this is how we are going to look in the upcoming 2 weeks. Is this okay to all of you? Yes? Yes or no? Everyone who is on live, type in the chat box. Did you all get the clear-cut idea of how the schedule is going to be? Which are the best subjects to choose for XE? वैसा नहीं होता है, it depends on your interest and strength in the subjects, obviously. ठीक है, ऐसा नहीं होता है कि fluid काफ़ी आसान आता है, thermodynamics काफ़ी tough आता है और solids काफ़ी आसान आते हैं, वैसा कुछ नहीं है। ठीक है, almost each and every subject is balanced. Maybe like 5-10% variations could be there, but in reality, the strength, the foundational knowledge or the fundamental knowledge that you have in each subject is the thing you should consider, okay, before you go for XE. Okay, you have design subject in XE to get design branch in MTech. Not exactly, but only in IIT Kharagpur there is this option that you should involve design subjects. Okay, लेकिन कुलदीप साहब आपके लिए आते हैं, like after the GATE exam is fully done, what is the admission procedures, cutoffs कितना है, ये सब के बारे में उन्होंने बताते हैं। ठीक है, so let's without any further delay let's start the first question. So this is a last year question. We'll start from the recent times. So 2024 में एक MCQ आया था, question 1, which one of the following figures shows the correct answer dependent of an apparent viscosity on rate of shear strain du by dy for pseudoplastic fluids actually. ठीक है, and the graphs are given between apparent viscosity and the velocity gradient or the rate of shear strain for small gaps. Okay, so if you see इस topic जहाँ जो types of fluids होते हैं, non-Newtonian fluids, okay, so every year you generally expect one question more or less. Okay, so if you see, normally this tau is given by tau naught plus a du by dy whole power n. क्लियर? सो इसमें जो इंपॉर्टेंट चीज़ है, क्योंकि मैं इस फॉर्मूला क्यों लिखा हूँ, क्योंकि ये काफ़ी रिपीटिंग टॉपिक है, ठीक है? सो इसलिए देन दिस इज द यील्ड शियर स्ट्रेस, यील्ड शियर स्ट्रेस, ठीक है? सो यील्ड शियर स्ट्रेस क्या होता है? नॉर्मली एवरी फ्लूइड डू नॉट डिफॉर्म infinitely under small shear stresses. Okay, normally water, air, these things deform, but if you take things like toothpaste, jam, these guys don't deform immediately. Okay, so they need certain strength, and this A is called flow consistency index, and this N here is called flow behavior index, मैं हर एक क्वेश्चन का कॉन्सेप्ट नहीं देता हूं, लेकिन ऐसा जो काफी रिपीटिंग टॉपिक्स होता है, सो वहां 1-2 मिनट थियरी भी डिस्कस कर सकता हूं, ठीक है? सो इफ यू सी नाउ, ऑल ऑफ यू माइट हैव सीन दिस ग्राफ, टाउ वर्सेस du by dy. Okay, so tau du by dy, then you can see Newtonian has tau not 0 and n is equal to 1, ठीक है? And these are Newtonian guys, Newtonian fluids, where A is equal to, or tau naught is equal to 0, n equal to 1. Tau naught equal to 0, इसका मतलब क्या होता है? When you make this expression, if you have du by dy, immediately you will have tau. That's what. Okay. Then there is one class of fluids which are harder to deform if you are increasing them, if you are trying to increase the deformation rate. मतलब like you have wet suspension of sand. Okay, sand is easy to displace slowly, but if you try to displace sand very fast, you will feel lot of resistance, correct? So these are those subjects, and they are dilatant. Okay, and normally if you take for tau equal to 0, tau can be written as tau naught is equal to 0, tau can be written as A du by dy whole power n minus 1 into du by dy. यहाँ जो टर्म है इसको कहते हैं कि हम apparent viscosity eta, correct? So that's the apparent viscosity eta, and obviously you have this set of fluids which are pseudoplastics. So इसमें क्या होता है? You can see this is tau is equal to some form of x, y is equal to mx form, so slope should keep decreasing. Okay, काफी टाइम्स लोग याद रहते हैं, ठीक है? जो लाइन न्यूटोनियन से नीचे होता है वो होगा डायलेटेंट, जो लाइन न्यूटोनियन से ऊपर होगा वो होगा pseudoplastic. ऐसा नहीं है, ठीक है? In some books, depending on the type of fluids, the graph can be like this. Okay, ऐसा भी हो सकता है, वैसा नहीं है कि ये dilatant है, नहीं, ठीक है? So you should be very careful. Now in this case, if you take the tangent slope, the tangent becomes flat and flat, but here the tangents go steep and steep. Okay, so in pseudoplastics, this eta decreases as du by dy increases. Okay, so du by dy increases, which tells you that eta will come down, because if you keep tangent, the tangent keep getting steeped in dilatant, and the tangent keeps getting flat in pseudoplastics. Clear? Like for example, you can see in this case, like butter, if you leave for 3-4 days, okay, then it gets diluted, or curd, if you leave for 3-4 days, it gets diluted. So things like this. Clear? So now you should focus on that line where in case of pseudoplastics, eta decreases as du by dy increases. Correct? Yes or no? Now tell me what should be the correct answer? Everyone, come on, आपके सामने 4 options है, ठीक है? मैं बीच में करता हूँ. So now tell me what should be the correct answer? If your du by dy is increasing, eta should come down. Okay? D, पक्का? Wrong. Okay? Because see, I know, इसलिए उन्होंने options में भी दिया था, but these are the graphs of tau versus du by dy. ठीक है? And यहाँ जो ग्राफ्स दिया था वो है कि eta versus du by dy. ठीक है? So this is actually wrong answer. Clear? Eta is not increasing with du by dy. Eta is actually decreasing. ठीक है? D is not the correct answer, क्योंकि यहाँ जो ग्राफ्स हमने बनाया था वो है कि tau versus du by dy. Okay? But यहाँ जो ग्राफ्स ऑप्शंस में दिया था वो है कि eta versus du by dy. Got it? Yeah? Everyone? Is this okay? क्लियर? सो इसलिए मैंने पहले क्वेश्चन यही किया था, बिकॉज आई नो मेनी ऑफ यू वुड गो विथ ऑप्शन डी, जैसे मैंने देखा था चार्ट बॉक्स में. ओके, सो बिफोर यू आंसर थिंक काम, बी काम. गॉट इट? चलो, लेकिन हर एक क्वेश्चन से कुछ तो कुछ सीखेंगे. नाउ सेकंड क्वेश्चन. नाउ टेल मी, MCQ 2024, for an immersed neutrally body to be in stable equilibrium, the center of gravity of the body is directly above the meta center, below the meta center, above the center of buoyancy, below the center of buoyancy. Okay, and it's a immersed. Okay, it's fully immersed and neutrally buoyant, of course. Okay, neutrally body. Then to be in stable equilibrium, you know, for completely submerged bodies, stable equilibrium implies G lies below center of buoyancy. Okay, I'm giving only 1 point because of this you can think. Now if I write 2-3 points like unstable, G above B, if I write these points you'll get confused. Okay, so I'm writing only one. जब stable equilibrium होगा तब G lies below B, and if the body is floating then यहाँ B की जगह से क्या आएगा? Come on, type in the chat box. If the body is floating, okay, not immersed, then for stability G should lie below what coordinate? Anyone? M. Okay, उस टाइम पे मेटा सेंटर पे डिपेंडेंट होगा. ठीक है, so for partially submerged or floating, you can say floating bodies, stable equilibrium implies G lies below meta center, okay, which is the instantaneous center of rotation of the body. Clear? Good. So M, badhiya. So in this case it's immersed, so clearly to be in stable equilibrium, the center of gravity of the body, the equilibrium is stable, so G should lie below the center of buoyancy. Okay, so G lies below the center of buoyancy. Clear? First 2 questions na, so thoda sa theoretical questions. Okay, we'll go to maths, like mathematical questions. Okay, so is this okay to all of you? Yes? Chalo. Well, let's go to next question. Come on, answer this. If you don't answer this, then it's difficult. Okay, so come on. A set of basic dimensions, mass, length and time are represented by MLT. ये भी 2024 में आया था. What will be the dimensions of pressure in MLT system? Come on, tell me. Answer कौन सा है इसका? ML power -1, T power -2, ML T power -2, ML T power -1, ML power -1, T power -1. कौन सा होगा इसका आंसर? Dhananjay, Pratik, Anurag, of course, lot of names, sorry, yeah, A, D, A, hey, jaldi, it's a simple question, no? Pick A, okay, so, chalo, let me do, kaun sa unit chahiye humko? Pressure, so P is equal to force by area, for example, if you say, in a loose sense, force, mass into acceleration, meter per second square. So this gives you m L power -1 T power -2. That's all. Okay. So m L power -1 T power -2. Very easy question, basically for 1 mark question. Okay. So m L power -1 T power -2. ठीक है. m L power -1 T power -1 नहीं है विभू. ठीक है. You can see there are T power -2. चलो good. Next. So let's solve this question. 2024 NET again. The velocity in a 1D flow is given by u of x is equal to a by b minus x whole square meters per second, where a is 8 meter cube per second, b is 4 meters. The acceleration, answer in integer. Okay, come on, do this. Solution. Given the velocity field is u component, a by b minus x whole square I cap. That's all. Okay, ठीक है, it's a 1D flow. That's what even they have given, 1D flow. Then a is equal to 8, so ठीक है, and b is equal to 4 meters. So acceleration कितना होगा बस. Okay, it came for 2 marks. Oh nice. So let's see, if you want acceleration, so normally क्या होता है, dou v by dou t plus v dot del operating on velocity, correct? So for 1D, if you simplify this, you would get only dou v by dou x, dou v by dou t, u dou v by dou x plus v dou u by dou y plus w dou u by dou z. I cap, बस इतना ही होगा acceleration, correct? So this is going to be acceleration. लेकिन यहाँ जो flow दिया था वो है कि steady flow, okay, steady flow, because there is no involvement of time. So this, there is no dependence on time. VW components नहीं है, so this is 0. So your acceleration is going to be u a by b minus x whole square into, now du by dou u by dou x, since u is only function of x, so is it from fluid kinematics? Yeah, of course. So you can see if you differentiate this, a है कि constant, then if you differentiate this function, -2 divided by b minus x whole cube. Okay, so this would be the value I cap, of course, correct? U into dou U by dou X. Now, if you substitute the values of A and B and X is equal to 2, इसका value कहाँ चाहिए हमको? At A is equal to 8, B is equal to 4 and X is equal to 2. ठीक है, substitute कर लो. तो कितना आएगा acceleration? ये which is 8 by b minus x whole square. b minus x is 2, so 2 square is 4 into minus 2 times a, which is minus 16, divided by then b minus a, 4 minus 2 whole cube, so 2 cube is 8, of course, I cap, so which is minus 4 times I cap, correct? Because you see this is minus 4a I cap. So what do you want? The acceleration in meters per second square. Answer in integer, of course. Okay. So anyway, they maybe just want the value. So this is minus 4. That's all. Means the fluid is practically retardating. It could be like a diverging nozzle in the subsonic flow limit. Okay. Polar coordinate system. Yeah, I'll give polar coordinate system. It is plus 2, no, sir? Is it plus 2? I plus 4. But they asked only about the acceleration. No, there is this minus sign, right? When you differentiate this b minus x whole power minus 2, you will get minus 2 by b minus x whole cube. So it's minus hoga na yahan. I am doing wrong or what? I trust my maths at least to some extent. U of x is equal to a by b minus x whole square. This is a function a into minus 2 b minus x whole power minus 3. That comes down 8, 4, 2. That's correct. Into minus 16 by 4 minus 2 whole cube 8. Yeah, I think minus should be there. Yeah, minus should be there. Okay, so minus 4 is the correct answer. Okay, then there is plus. Yeah, of course, correct. It should be plus. This derivative b minus x has inner derivative. Yeah, of course, correct. Sorry, I missed this minus sign. This is the reason why I do wonders in exam every time. So this should be plus 2. Okay, so everything is plus. Then this is plus 4, 2. Okay, because differentiation of b minus x should also be there. It's minus 1. So that minus 1 should be multiplied there. Okay, is this fine to all of you? Yeah, those who have typed 4, it's correct answer. Okay, it's not minus, it's plus 4x. This differentiation is plus 2. क्योंकि minus 2 by b minus x whole cube into minus 1 भी आएगा. Okay, so the correct answer is 4. Anyway, the integer is 4 and it's along the x direction. It's 1D flow. Okay. So let's solve this 2023. Question number 7. A stationary object. Okay, 6 questions हम solve किया था already. Good. So a stationary object is fully submerged in a static fluid as shown in the figure. Here CG and CB denote center of gravity and center of buoyancy. Which one or S? MCQ I think. Oh, MCQ. Okay, fine. Which one among the following statements is or true? Of course. Okay. The object is in stable equilibrium. Then this should be MSQ. Okay. It's MSQ. Then the object is in stable equilibrium if YCG greater than YCB. What is the meaning of this? If this is the coordinate point of CG, then this distance is YCG. Okay. And this distance here is YCB. Okay. And if this body has to be in stable equilibrium, then definitely, you know, YCG should be more. Center of gravity should lie below center of buoyancy. So YCG greater than YCB means it's stable equilibrium. Correct. The object is in stable equilibrium if YCG less than. This is wrong. The body is in neutral equilibrium if both are equal. Correct. There won't be any buoyancy force in that case. Unstable equilibrium if equal. No. If it's equal, then it's neutral equilibrium. Both the points gets coincided. Okay. Yes. Come on guys, type in the chat box. You can see this question came in 2024, 2023. It keep the questions from types of fluids, these conditions of stability, they keep coming up again and again. Okay, so you should be careful. Yeah. Chalo. So let's solve this question. In a steady 2D compressible flow, U and V are the x and y direction components of velocities. Okay, and what is that fluid density? Among the following pairs of relations, which one or S perfectly satisfy the definition of stream function psi for this flow actually? Okay, so if you see solution, normally if you look at the components, okay, so U is given as, velocity field is given as Ui plus Vj actually. Yes, now come on, type it in the chat box. What could be the actual answer in this case? A, C, I'll give you 1 minute time, you can think. Okay, A C B, अरे कहीं ने D भी टाइप कर लो ना, सारे ऑप्शंस कवर हो जाएगा तब. A C D B. Think, what's the definition of the stem function first? What is the definition of the stem function? See, look here. We'll solve. Normally, if you have a stem function, if you have a stem line like this, and this is given by some function. Okay. So definition क्या होता? But signs are opposite. Let's see. Okay. This tangent is velocity. Correct. And if you want to get the equation of this stem line, so how would you get this? Normally, along a stem line, d psi is equal to 0. So dou psi by dou x dx plus dou psi by dou y dy is equal to 0. Correct? That's what you would get. Okay. And also, if you see, this equation of the stem line can also be written as, if this is ds, okay, where ds is something like dxi plus dyj plus dzk. Okay. Or let's take 2D for the time being. Then how do you define this velocity vector? Is velocity at any given point p, let's say if you call this point p, then velocity is always tangent to the stem function. Correct? Agar this v and this ds, ये दोनों tangential, like if this v is perfectly tangential to ds, what should be the cross product? V cos, or maybe ds cos v. What should be this value? Anyone? Any one of you, come on, tell me what is this value. ये इसका क्रॉस प्रोडक्ट कितना होगा? दो वेक्टर्स है आपके पास एंड दोनों वेक्टर्स ऐसा ही है. ठीक है. सेकंड वेक्टर इज ऑलमोस्ट टेंजेंशियल टू द फर्स्ट वेक्टर, तो इसका वैल्यू कितना होगा? 1. इंदु, did I teach 1? 0. Okay, it's 0 because you can see this is 0 bar. That's how you get the streamline equation as dx by u dy by v dz by w basically. Okay. And how is velocity potential function defined? Normally v is equal to gradient of phi. Correct. So because of which, if you compare these two, okay, like you can see for 2D, so for let's say in the z direction, if you are changing the things, not changing the things, ui plus vj. So this implies dx by u is equal to dy by v. So this gives you v dx minus u dy is equal to 0. And what about this equation? Dou psi by dou x dx plus dou psi by dou y dy is also 0. If you multiply this with minus, then you can see u is dou psi by dou y and v is minus dou psi by dou x. That's all. Okay. So this is what you get. And normally, anyway, in the maths class also we'll see today. Maths थोड़ा सा fun है, ठीक है? So we'll see. Normally जब मैंने maths पढ़ाया था, उस time पे मैंने काफी batches में पढ़ाते हैं. If you see, this is some function. Okay. At this point, if you take a normal, this normal is given by gradient of phi, which is velocity. Okay. And the stem functions are such that this same velocity is like tangent to this stem function. Okay. The stem function is such that this same velocity is tangent to this curve. So for one curve it is normal, for one curve it is tangent. Then what should be the angle between these two curves when they are intersecting? Correct now? Velocity is given by the gradient of the scalar point function. V is equal to grad phi. So gradient geometrically means it's a normal to the surface. So for one curve, this vector is a normal. For another curve, this vector is a tangent. Then what should be the angle between those two curves? What is the angle between tangent and normal? Come on. 90. That's all. So that's why phi and psi are always perpendicular to each other. Simple logic. Okay. The definition of the stream function is velocity is tangent. Okay, the definition of velocity potential function, velocity is normal. So those two should be at 90 degrees. That's why the lines of equipotential and stream lines are zeros. Okay, stream function exists only for incompressible flows, and fluid can either rotational or irrotational. The statement correct or wrong? First of all, incompressible fluid. No, even incompressible flows of gases and all, we deal with stream functions. Okay. When function is incompressible, need not be, no. See, psi comes out not from the compressibility effects. Got it? In case if you have studied this statement, when stream function exists is only when function is incompressible. No. Only when flow is incompressible. Even in compressible flows, you have streamlines, correct? Particles can float and you can have streamline definitely. At every point you have velocity, so you can always generate a curve for which the tangent is the velocity. Correct? Yes, no? Did you all get this? Like even if you have compressible regime, even then you can see the gas particles moving, and definitely at every point you can have the velocity. Okay, and if you know the tangent, you can keep generating the curve. That's what your Angikata fourth order methods, all these things. Okay, numerical schemes. So anyway, so this is what we have, and if you take that, V is equal to gradient of phi. So dou phi by dou x I cap plus dou phi by dou y j cap. Okay, so in this case, dou phi by dou x is equal to dou psi by dou y, and dou phi by dou y is equal to minus dou psi by dou x, and these are the 𝐂𝐤𝐴 equations, useful for potential flows very much. Anyway, maths में भी पढ़ाएंगे आज रात 7 to 10 फर्स्ट सेशन में. Okay, that's all. Okay, TI equations, the 𝐂𝐤𝐴 equations basically, but this is how it comes up. Okay, so that's how the potential flow theory is based on this. Like for example, if people have told you that somewhere somehow, if you have learned that stream function exists only for incompressible flows, then you can see this is a compressible flow, but options are given for stream function. Okay, it's a simple logic that it exists. Or else even compressible flow, incompressible flow, definitely fluid particles move. Okay, so definitely at every point you have velocity. So if you have a tangent at every point, then you can keep constructing a curve. That is the stream function. Okay, chalo. So anyway, the correct answer is u is equal to dou psi by dou y and v equal to minus dou psi by dou x. Clear? Because of this logic. That's why A is correct option, of course. Okay? Is this okay to all of you? Come on guys, type in the chat box. Is this okay? Yes? I thought of giving you this because if these two are perpendicular, then at the point, if you take the derivatives, dy by dx gives you slope, correct? This is -1 because these two are perpendicular to each other. They intersect perpendicularly. Chalo. Let's see. काफी time हो गया इस question में. Now let's see. 2023 again last year का question था. Water of density 1000 kg per meter cube and alcohol of specific gravity 0.7 enter a y-shaped channel. ठीक है? So यहाँ की एक y-shaped channel at a flow rate of 0.2 meter cube per second and 0.3 meter cube per second respectively. Their mixture leaves to the other end of the channel as shown in the figure. The average density of the mixture. Okay, so you know whatever is the mass flowing, and here they are mixing. Okay, alcohol and water they mix, no? Yeah, they mix of course. Alcohol and water, so they are mixing. So what should be the exit density? Okay, so this is section 1, this is section 2, and this is section 3. Very cute questions come in GATE nowadays. So if you solve from continuity, then if you take this control volume for example, okay, let W be width of the channel, perpendicular to board. Okay, so this implies summation m dot for the control volume should be 0 at steady state, right? So this should be at steady state. Okay, and clearly you can see here they have given y-shaped channel at flow rates. Okay, the mixture leaves the other end to the, and obviously channel cannot hold any liquid, okay, so it should send out. So this gives you m dot 1 plus m dot 2 is equal to m dot 3. Clear? So m dot 1 actually, okay. So the discharges are given: water of density 1000 and flow rate of 0.2, alcohol of specific gravity 0.7 and discharge of 0.3. So we can write rho alcohol into q dot alcohol plus rho water. Okay, first water is given, so let's write sequentially. So density of water, discharge of water, density of alcohol, discharge of alcohol is equal to rho mix into the discharge at the mixture, okay. So the average density kg per meter cube, leaving the average density of the mixture is dash, okay. So what else they have given? Nothing. Rho q, that's all, okay. So the total discharge, average mixture density is what they are asking. So q dot mix, of course. So since dimensions are not given for this channel, only discharges are given, then you can see rho mix is equal to summation rho I q dot I by summation q dot I. So which gives you density of water 1000 into discharge of water, water is 0.2, plus per alcohol it's 0.7, so 700 into 0.3 divided by summation of the discharges, 0.2 plus 0.3 is 0.5, correct? That's all. So if you simplify this value, you would get the answer in kg per meter cube. The total discharge, both are liquids, so the discharge remains the same. So 1000 into 0.2, 200 plus that is 700 into 0.3, 210. So 410 divided by half, 820 is the answer. 20 kg per meter cube, that's all, okay. So 820 kg per meter cube should be the actual density of the mixture when it's coming out. Yeah, okay. See, if these dimensions are given, then it's a different story, but like यहाँ कुछ dimensions नहीं है हमारे पास, so the discharge should be same. Fine. Everyone, type in the chat box. Is this okay? Yeah. So let's move to this question. 2023 again. A stationary circular pipe. So हमारे पास एक circular pipe है of radius r is equal to 0.5 meters is half filled with water. So the pipe is only half filled with water. The radius is r, whereas upper half is filled with air at atmospheric pressure. So here the pressure in this chamber is P atm, and outside this pipe also it is P atm. Good. Then it's okay. As shown in the figure. Acceleration due to gravity is 9.81. Magnitude of the force per unit length rounded off to 1 decimal applied by the water on the pipe section AB. So where is AB? Here. Okay. So this is A until here. This is B, of course. Okay. Now, if you construct this, I'm a very bad artist. Okay. So please spare me for some time with my bad artistic skills. Fine. So then we create. Okay. So till here we'll create this. Good. Okay. So now let's see. Here there is water. Okay. So the pressure at this point is P atm local. So this is free surface, and outside also you have the P atm local. So definitely you know one thing. If the fluid is here, the hydrostatic force would be definitely passing to the center, correct? So this, let's say if this is the hydrostatic force, for example, the total hydrostatic force FH. Okay, this hydrostatic force will definitely pass to the center of that quarter. Yeah, yes or no? Because the any normal at any point should be the radius to the circle. Okay, so now if you use all this, you have Fx and Fy. So how do you do them? Let the hydrostatic force is equal to Fx I cap plus Fy j cap. for example, where this Fx is the x component of the hydrostatic force, Fy is the y component of the hydrostatic force. Okay, so length of the gate is 1 meter, which is perpendicular to this board. Okay, and you have the radius r, for example. So if the radius is r, we don't know what is the r value as of now. Okay, given 0.5 meters. Good. Then Fx is equal to, so how do you calculate the hydrostatic component? Okay, so if you take a projection onto a plane perpendicular to x-axis, you would see a rectangle here, correct? This is how you would see the rectangle. Then if you mark the x bar of this height would be, how much it is? This is total r, so this would be r by 2, and this is 1 meter into the plane. So the hydrostatic force Fx is density of the fluids g into projection of the surface perpendicular to x-axis. Okay, because if you are talking about x direction force, projection of the surface should be taken onto a plane that is perpendicular to x-axis. Okay, so if you project perpendicular to x-axis, this is a rectangle you will see. Okay, so then, but AB is only quarter circle. Okay, got it? They are interested only on force acting on AB. So AB है सिर्फ एक ही quarter. So then Ax is r by 2 into 1 into h bar. The depth of centroid from the free surface is r by 2. So which is rho f g r square upon 4. So that is this Fx value. So what would be Fy? Fy, y direction. If you take this as the y direction, for example, y direction, then the y direction force is nothing but the weight of the fluid supported by the gate, correct? Because anything in the vertical direction, if you take the plane perpendicular to z-axis, you will completely get the z direction. I'm not deriving as of now, but normally in detailed courses and all we would derive. So you can see the Fy is weight of the fluid. So weight of the fluid is how much? Density into gravity into the volume. So this area of the cycle, pi by 4 r square into length is 1 meter. So this would be rho f g pi r square by 4, but with a minus sign. Why a minus sign? Because the force Fy component is in the downward direction. Okay, so that's why. So therefore magnitude of Fh is equal to root of Fx whole square plus Fy whole square. So this is rho f g r square by 4 into root of 1 plus pi square. That's all, correct? So that would be the value. Area should be r into 1. Which one? Yeah, correct. This should be r into 1. 2. So here you should have, oh sorry, this will disturb this, I think. Okay, so if you see, this is r into 1 because this total height is r. Okay, so this is rho f g r square by 2, of course. Okay, and this is rho f g pi r square by 4. So if you take the values, rho f g r square would come out into root of 1 by 2 whole square, 1 by 4 plus pi by 4 whole square, pi square upon 16. Okay, so this would be the value. पिछले साल के XC रैंक यूज करके IISc के एडमिशन ले सकता है क्या? अभी उसका फॉर्म आया है, या यू कैन यूज गेट स्कोर का वैलिडिटी है कि 3 साल, ठीक है? सो इफ यू वांट टू अप्लाई नाउ इन 2025 यू कैन यूज द स्कोर ऑफ 2022 ऑल्सो. क्लियर? एट द टाइम ऑफ अप्लाइंग यू शुड हैव 22, 23, 24, but 22 form will get outdated until I think March 17 or 16th. Before that, if you apply, it's okay, but at the time of application better to use 23 or 24 forms, okay, so that this date wise issues won't come. Okay, chalo, let's solve this. So therefore magnitude of the force is equal to density. So fluid kaun hai? Fluid is water, so 1000, g 9.81, r square, radius is 0.5, so 0.5 square into root of 1 by 4 plus pi square upon 16. बस कैलकुलेटर लेके फटाफट कर लो सॉल्यूशन. pi square by 16, so pi square this value by 16 plus 1 by 4 which is 0.25. so this value square root into 0.5 square, so 0.25 into 9.81. So 2.283. That would be the force. Okay. Fy में y negative sign because normally the coordinate is x, y. That's why. Okay. But anyway, यहाँ हम सिर्फ magnitude calculate कर रहे, so कुछ नहीं होगा. We can use this. It's okay. Fy is negative because the vertical force will be acting downwards. इसलिए, like if I want to write this force, for example, rho f g r square by 2 I cap minus rho f g r square into pi by 4 j cap. That's the hydrostatic force. That's the reason. Okay. Is this clear to all of you? I think मुझे लगता है कि 2 marks के लिए आया था. But anyway, it's a simple question. Only these 2 steps. Is this okay to all of you? Anyone with the issue of writing r into 1, pi by 4 r square into 1? Is this okay to all of you? Everyone on live. Come on guys. Calculation गलती आ गया क्या? और सही है. I think it's good. Okay. एक छोटा सा डाउट था. Should I choose subjects in exam itself or to be clear from now only? Clear from now. Okay. So chalo, its question is correct. Okay. If you want theta value, let's say if you want to know what are the coordinates of this point, for example, कैसे करते हैं? You can calculate this theta. कैसे? Because you know fx, fy, so tan theta is equal to mod fx by fy, sorry, mod fy by fx, then you'll know this theta, you know this radius, so you can calculate the coordinates of this point. That's how you calculate the coordinates of center of pressure in curved surfaces. Okay. So 2.283, लेकिन एक डेसिमल तक राउंड ऑफ करना पड़ेगा, so 2.3 kilonewtons बस. Okay. चलो, let's go to the next question then. Yeah, 11th 2022. A flow has a velocity potential function given by phi is equal to x cube. A is non-zero. Which of the following statement or statements is or to about the flow actually? Okay. Flow is incompressible. Flow is irrotational. Flow has local acceleration. Flow has convective acceleration. Bas. Chalo. Let's start. Phi given. Phi is equal to ax cube. Okay. And A is non-zero. So if you want velocity vector, gradient of phi, so this gives you 3ax square I cap bus, because there is no y and z components involved. Okay, so v is gradient of that function. So if you have a scalar function, then if you calculate the gradient, dou phi by dou x I cap, dou phi by dou y j cap, all this stuff. But this function do not have y and z involvements. Okay, so 3ax square I. Now let's see. First, the flow is incompressible. So first, for incompressible flow, and A is non-zero. Okay, it's given in the question. A is a non-zero constant. Okay, so for incompressible flow, divergence of velocity should be 0, right? So if you take divergence of velocity to be 0, then this gives you dou by dou x of 3ax square, that's all, is equal to, which is 6ax. Now tell me, is this function 0 at every point? A is non-zero, 6 is positive constant of course. Then is this function going to be 0 at any point in the flow? Is it? Come on, tell me. No. Correct? जब x 0 होता है means along the x axis, only along x axis, sorry, x 0 means only along the y axis you have this compressibility equation, incompressible flow equation getting satisfied. Otherwise it's not incompressible. Okay, so which is not 0 for all x, so therefore it is not incompressible. Okay, then irrotationality. So how do you check the irrotationality? Like for example, v is equal to 3ax square I cap. Okay, then take curl of v, which gives you I j k dou by dou x, dou by dou y, dou by dou z, then 3ax square 0, 0. So clearly you can sense this is 0. So the flow is irrotational. Okay, so you have a irrotational flow field. Definitely curl is 0, so you have irrotational flow field. The flow has local acceleration. So what is local acceleration? The dou u by dou t term. Okay, but there is no involvement of t here, so definitely there is no, because it's a steady flow, so no temporal accelerations. So this is wrong. It has convective acceleration, pretty much correct, because if you do u into dou u by dou x, that's non-zero. Okay, 3ax square into 6ax, you will get 18a square x cube, which is non-zero at all the points. Clear? So that's why B and D should be the correct answers. Which of the following statements are true? So yeah, B and D are the correct answers. Okay, because it's steady flow, no? Like if you see, dou E by dou T is equal to 0. So this implies no temporal acceleration or local acceleration. U into dou E by dou x is equal to 3ax square into 6ax, which is 18a square x cube, not 0 for all x. So this implies convective acceleration is non-zero. Okay, that exists. So B and D are the correct answers. Yeah, of course, B and D are the correct options. Okay, it's fine to all of you. Everyone, see, all these are PYQs. Okay, देखने में लगता है कि क्वेश्चंस काफी आसान है, but these are the actual questions which come in GATE exam. MCQ or MSQ? It's MSQ, no? Statement is or MSQ. Yeah, maybe a small typing issue, but it's an MSQ. Okay, issues. Yeah, fine. Chalo, let's solve this. Question number 12, NAT 2022 say a wooden cylinder, specific gravity 0.6 of length L and diameter D, floats in water. Find out the minimum value of D by L for which the cylinder floats with its axis vertical. Okay, with its axis vertical. So let's see, there is a wooden cylinder like this. Okay, it's a wooden cylinder. Okay, and let's say it's floating about this point, for example. Okay, so it is flowing about this point and this is the free surface. Now इसका diameter है कि D and this length is L. This length is L actually. Okay, flow net is important for XC. Generally flow net is nothing, it's the net found by the equipotential lengths and the stream functions, but no issues. Okay, like whatever the data I have covered in somewhere, third or fourth question, like about stream functions and velocity potential functions, that's enough. So let's see. So it's a wooden cylinder. So obviously if you project this water line, okay, if you project this water line, means this line will go up to this point. So definitely if you cut at the water line, the cross section you see will be a circle. Okay, you know this. And this cylinder is floating. Wooden cylinder of specific gravity. So specific gravity of wood is how much? Okay, wood, let's write. Wood is 0.6. Length L, diameter D, floats in water of density rho, 1000 kg per meter cube. So this is density of the water, for example, water. Then the minimum value of D by L for which the cylinder floats with its axis vertical is how much? Okay, so let's see. First of all, if the cylinder has to float, if this value is h, small h, let's say. Okay, so this is small h. Under this condition, this cylinder is floating, okay, with axis vertical, something like this. Okay, then you cannot see this obviously here. Okay, so that's the axis. Okay, so for floating initially, weight of wood should be balanced by buoyancy force due to water, correct? So what's the weight of the wood, density of the wood into volume? So what is the volume? Pi by 4 d square into L. So this is the volume of the cylinder into G. So this is the total weight of the wood. Now this is being balanced by the water. Okay, so density of water G into what is the volume displaced? This which is submerged. So pi by 4 d square h. So if you do this simple equation, then pi by 4 d square, pi by 4 d square, G gets cancelled. So h is equal to L into specific gravity of the wood. This is the first condition. Yes or no? Type in the chat box. It's a one line till now what I have done. Okay, just the force balance equation, sigma Fy has to be 0 for the body to float first of all. So whatever is the weight of the wood, same should be the buoyancy force acting by the water, and those two balance each other. So h is equal to L times specific gravity of the wood. Okay, now with its axis vertical it should float. So how do you do that? If this has to be in stable equilibrium, okay, so for floating in stable equilibrium, Gm should be greater than or equal to 0, which tells you metacentric radius minus Bm, the distance between, so sorry, Bm minus Bg, metacentric radius minus Bg should be greater than or equal to 0. Like let's say for example B is here, okay, then G is let's say somewhere here, then metacenter is somewhere here, okay, because it's floating. Then if you see balance equation once again, yeah, weight of the wood, density into volume, so mass of the wood into gravity, buoyancy force acting, density into displaced volume into G, okay, as per Archimedes principle. You know, like if you submerge a body to some part in the fluid, then whatever is the volume that is displaced by this body, so specific gravity of that fluid into, sorry, not specific gravity, specific weight of that fluid into the volume which is displaced. This is the Archimedes principle, okay, the condition for floating. Now let's see what would be Bm. First of all, this B, center of buoyancy, is this h by 2 actually, okay, and G is nothing but L by 2 obviously, okay, because center of gravity of the body is exactly at half of the height from the base, and center of buoyancy is exactly at half of the submerged portion. So this Bg distance is L by 2 minus h by 2, L minus h by 2. So now what about Bm? So how do we calculate the Bm? Bm is nothing but Iyy by volume submerged. So who defines this axis Yy? If you make a cut at the water line, many times people see you look from the top, so whatever the geometry comes, so take moment of inertia of that geometry. That's not always the case, okay, because these things happen only if the body is prismatic. If the body is not prismatic, then if I have a cone for example, then you should definitely cut, okay, sorry, Gatopedia, sorry, didn't get fluid mechanics, Gatopedia, so your handwritten, yeah, other faculty, others, not me, okay, because at the time of launch some other has done that document, okay. Chalo, let's see if this is D, M, G, B, okay. B is the center of buoyancy, half of the height, so G is the center of gravity, we have the total half of the total height. So what I was telling, if the body is not prismatic, okay, like if you have a cone, then you cannot draw the circle by looking at the top, because the diameter of the cone on the top is different from the diameter at this water line cut, okay. So this cross section is always that cross section of the water line cut, okay, clear? In exam if they give cone, will you put capital D? No, okay. So you should make a cut at the water line and then you should see the cross section at that cut water line, okay. Now YY axis is nothing but at this water line, the axis which is perpendicular to this, okay, the axis which is perpendicular to the board, which means in top view you will see this is the axis, okay. So this is YY, of course, normally the least moment of inertia axis, but anyway in case of cycle both are same. So this gives you Bm pi by 64 d power 4, sorry, d power 4 by submerged volume pi by 4 d square into h. This is the submerged volume actually here, okay. So if this is a submerged volume, then pi by 64 will give you 16, this gets cancelled, so 1 by 16 d square by 16 h actually, okay. So that's the metacentric radius, so d square by 16 times h. Now what is the value we want? We want d by L value. So let's do one thing, यहाँ जो h है उसको L में सब्स्टिट्यूट करेंगे. So what's the relation? H is equal to L times specific gravity of the wood. So this equation becomes d square by 16 minus d square by 16 if you multiply with h all over, or else 16h. So h is L times specific gravity of the wood, okay, minus half into L minus h. So L minus L specific gravity of the wood, so L into 1 minus specific gravity of the wood. This should be greater than or equal to 0. That's all. Okay, now you have everything in terms of d and L. If you take simplify certain things, okay, to cancel this 8 times, okay, then what is the value of specific gravity of the wood? Wood specific gravity is 0.6, so this is 0.6. So 1 minus specific gravity, this is 0.4. So if you see this equation, d square by 8 into 0.6, 4.8 into L minus d square by 4.8 into L minus, you can see L into 0.4. So 0.4 times L should be greater than or equal to 0. That's all. So from this equation, if you bring this term here and bring the L down, you'll see d by L should be greater than or equal to square root of 0.4 into 4.8. That's all. So d by L should be greater than or equal to 0.4 into 4.8 square root, 1.3856. That's all. So the diameter to the length ratio should be 1.38. Okay, did you understand? See, when I solve this, it looks like a big question, but actually it's a very small question, because this is one line what you write. Then if you know the values, if you have this figure, you'll write this equation directly, or maybe you'll do some small calculation. That's all. Okay, did you all understand what has happened here? So d by L value should be greater than or equal to 1.3856. Any doubt to any one of you? Because I many times see people बायोलॉजी का क्वेश्चन जब सॉल्व करते हैं उस टाइम पे मेटा सेंटर कैलकुलेशंस का क्वेश्चन जो होता है उसको नेग्लेक्ट करते हैं, ठीक है, बट दे एक्चुअली कम अप. So how you get the body is partially floating, not fully. Full floating, what do you mean by fully floating? Why it's not fully submerged? Is it because obviously you can see it's a wood, okay, and wood generally floats, and you can see that's how it's mentioned. Even a wooden cylinder floats in water. Okay, so जब आप क्वेश्चन सॉल्व करते हैं, ओके, एक्सी के लिए प्लीज डू सॉल्व क्वेश्चंस ऑफ मेटा सेंटर कैलकुलेशंस आल्सो. ठीक है, काफी लोग बायोलॉजी का क्वेश्चंस करते हैं, मतलब बायोलॉजी फोर्स का जो क्वेश्चंस होता है वो क्वेश्चंस करते हैं, ओके, आइस क्यूब फ्लोटिंग, ऑल दिस क्वेश्चंस यू डू, बट यू विल लीव द मेटा सेंटर कैलकुलेशन क्वेश्चंस. ऐसे मत करना, सबके सब 100% ऑफ द सिलेबस कवर करके जाइए, ठीक है. यस, चलो, गुड. Now let's move to the next question. See, normally जब आपको इस फॉर्मूला यहां तक याद होता है, I can also give you one small this thing. You can see if you want d by L normally for wooden cylinders, this is greater than or equal to, okay, so this is greater than or equal to 1 minus specific gravity of the body which is floating by specific gravity of the body. Okay, so you can see this is into specific gravity of the body here. Okay, so square root of 8 times Sg into 1 minus Sg, this whole power half. So if you substitute, you will get the same answer. Okay, yeah, this is what you can mark if you want, but this is valid only for this cylinder case. Okay, if they change the geometry, then it's not a very happy thing to do. Okay, in case of floating, is there a question on neutral equilibrium condition? Then in that case these two should be equal. Okay, then they can ask you like what is the value of d if L is given, or things like that. Other cross sections about which axis? See, generally if you take cone, cylinder, okay, you will see about this axis, about any axis, but in case of rectangles and all, the minimum moment of inertia is about this axis. So normally, ideally, if you take in general, in majority of the cases, at least 95% of the cases, the axis which is perpendicular to this, okay, at the point of water line, whatever is the axis perpendicular here, that axis is the moment of inertia axis. Okay, so that axis decides how you go for the things for the moment of inertia calculations. Good question, right? So 3 decimal places. So answer kitna hai? 1.386. Okay, so 1.386. That's all. So let's solve this 2022 again. Question number 13. The horizontal belt of negligible weight, as shown in the figure, moves with a steady state velocity of 2.5 meter per second and skims over the top surface of an oil film. So skimming means it just pulls the oil about. Okay, depth is 3 centimeters over the top surface of an oil film of depth 3 centimeters. So this is 3 centimeters. Length and width of the belt are respectively 2 meters and 60 centimeters. If the viscosity of the find the viscosity of the oil, given that minimum power required to move the belt is 100 watts. Neglect the end effects. Okay. So there is nothing mentioned about the pressure gradient also. Good. Okay. So correct na? Nothing, no information about the pressure gradient. So let's see the minimum power required to move the belt. So what is the power you need to move this belt? That's all. Okay. So this question is very similar in idea. So if you see, then you have a moving plate on the top. You are pulling it at a velocity v. Okay. So and in between you have oil. Some viscous oil is there. This h is known to you. Plate length is also known to you. And width of the plate perpendicular to the board is also known to you. Okay. Then what they are asking? Find, given that the minimum power required to move the belt is 100 watts. Okay, what to find? Find the viscosity of the oil. Okay, in Pascal second. Okay, so let's see. First, if you want to know the power in moving, and belt is a continuous system, no extensions, no compressions in between, let's say. So it's a uniform length total. So power is equal to force that you need to pull this plate. So let's say if you are pulling this plate with a force F, then this force into the velocity of the plate actually. Yes, so power is equal to force into velocity, linear mechanics. Then if you simplify this, so what should be the force? If you see, if this is moving at uniform velocity under the application of a force F, bottom there is fluid in contact, so definitely there is also the viscous force acting on this plate. Okay, but it's given V is uniform, so it's moving at some constant velocity. So definitely if you take this as the x direction, sigma fx should be 0 because net velocity is uniform, it's constant. So F should be equal to viscous force. Okay, so the force acting on the plate should be same as the exact amount of viscous force. Otherwise there is net force on the plate and plate will accelerate, which you don't want. Okay, so power is equal to viscous into this velocity. So Fv can be written as, so how do you can write Fv? The shear stress acting at the belt into the total area of contact, which is length of the belt is L, width of the belt is W into V. So P is equal to, tau can be written as, now this is a plate. Okay, we want the viscosity and there is no pressure gradient. Okay, so nothing is mentioned. So if you take the normal plane quiet or the simplified quiet flow, you have a linear velocity profile in this case. Okay, because normally these belts, conveyor belts, are exposed to the same atmosphere, so the pressure at every point is same, so you don't have to be worried actually. Okay, so given that minimum power, in this case tau mu into Newton's law of viscosity, for this linear velocity profile you can get velocity gradient. So if this height is h, here the velocity is 0 because of no slip, and here the velocity is v, velocity of the fluid layer which is moving is also v. So then v by h, L into W into v, of course. Okay, sorry, something is going. Okay, so now you want mu. So mu is ph by p into h by mu, sorry, mu is not there, L W V square, that's all. Okay, so mu v by h into L into W into V, that's the pure expression you have. So let us substitute the values, that's all. Anyway, you have the expression. Power, so what is the power value? Power is 100 watts. H is the spacing between the plates, so spacing is 3 centimeters oil film, so 3 into 10 power minus 2. Well, let us write everything in SI units. Okay, length of the plate is how much? 2 meters, and this is 60 centimeters, so 2 into 60 centimeters, 6 into 10 power minus 1, 0.6 meters. V square, so what is V square? 2.5, so 2.5 square, that's all. Okay, so this is the value that you have. So let's see. So 10 by 4 into 6.25, 10 by 25, so 2 by 5, which is 0.4, that's all. Yeah, 0.4 Pascal second. So the dynamic viscosity of the oil is 0.4 Pascal second. And what are the units they're asking you? In Pascal second. Okay, good. So 0.4 is the straightforward answer. No need of even calculator to solve this. Sequence and series in XC Maths we have to study, sir. I'll teach you, okay, today. We'll solve questions of sequence and series, and along with that also some concepts. Okay. So is this okay to all? Confirm? 0.4 is what you're getting. Okay, 10 by 25, that's all. So 0.4. Fine. It's a very simple, straightforward question. No issues. Correct, no? Yes. Good. So let's go to the next question. 14. Again 2021. A question from 2021 NAT. The 2D velocity field of a flow in a Cartesian system is given as dimensionless form by V is equal to x square minus axy I cap plus bxy minus y square j cap. Okay, here I and j are unit vectors along the x and y directions. Okay, directions a and b are independent of x and y and time. If the flow is incompressible, then the value of a minus b. Okay, so the flow is incompressible flow, so definitely it should satisfy the continuity equation, I mean the incompressible flow continuity equation. So let's see. Given this velocity is x square minus axy I cap plus bxy minus y square by 2 j cap. Okay, so clearly you can see continuity equation rho v is equal to 0 or dy by dt plus rho times divergence of velocity is equal to 0. You can use any of these two things. Okay, now it's anyway incompressible, so this is 0 because in the question it's given it's incompressible flow. Okay, if the flow is incompressible, then this term is 0, so it should satisfy divergence of velocity has to be 0 for incompressible flows. Okay, so that's for the incompressible flow. When will be the thermodynamic sessions? First, like the fluid and math sessions gets happened in the first 3 days. Then in the next 3 days, like Friday, Saturday, Sunday, you will be having thermo and solid mechanics sessions. Okay. Okay. So let's see. So this implies dou by dou x in Cartesian anyway. So dou by dou x of x square minus axy plus dou by dou y of bxy minus y square by 2 is equal to 0. Okay, so this gives you 2x minus ay plus by minus 2y, sorry, bx minus 2y is equal to 0. So this has to be zeros, of course. Okay, now if this equation has to be satisfied at any point irrespective of the coordinates, okay, at any point in the field, which means 2 plus b into x minus a plus 2 into y is equal to 0, for example. Okay, so if you take this equation should be satisfied at any point in the flow. When can that happen? Means what are the values of x and y you substitute, this equation should always be satisfied. When can that happen? Come on, tell me. So when can that happen? This equation should be satisfied at any values of x and y. You put any values of x and y, this should get satisfied. So when will that happen? Both are equal? No. That happens when this 2 plus b is 0 and a plus 2 is also 0. Then this equation becomes an identity at any points of x comma y. A plus 1, is it? 2x minus ay plus by bx minus 2y square by 2. Achha, y square by 2 is there, so there is no 2 here. Yeah, correct. Yeah, it should be 1. Okay, so these two should be 0. Okay, both the coefficients should be 0. Only then this becomes identity and the equation gets satisfied at any point. Chalo. So this implies b equal to minus 2, a equal to minus 1. So value of a minus b is 1. That's all. Okay, like for example, if I say ax plus by is 0 for all x comma y, this can happen only when these coefficients are zeros. Otherwise you cannot make them zeros. Okay, yes, no, something. No, it's okay. Simple question, no? That's all. It should be a plus 1, right? Yeah, it should be a plus 1. 2, because there should be only minus 1 because there is a 2 in the denominator here. Okay, so it should be 1. 1 is the answer. Next, 15th question. 2021 2D Eulerian velocity field is given by v is equal to root 5x I cap minus root 12y j cap. X and y are the coordinates in meters in a Cartesian coordinates. Magnitude of the acceleration in meters per second square of a fluid particle at x equal to 1 and y equal to minus 1. And clearly flow is steady flow. There is no involvement of time anywhere. So let's see. Given velocity field root 5x I cap minus root 12y j cap. Okay, x and y are the coordinates in meters. Okay, magnitude of the acceleration. So how would you do the magnitude of acceleration? W by dot t plus v dot del operating on v. So clearly this velocity doesn't have any time involvement, so this term would be 0. So this gives you v dot del, so u into dou v by dou x. Okay, u into dou v by dou x. Dou v by dou y, dou v by dou z is 0, so this is I cap plus similarly the v component of acceleration u into dou v by dou x. Okay, so v into dou v by dou y j cap, and that's all. It's 2D. So acceleration vector is 5x I plus 12y j. Okay, now you want this vector at the point x is equal to 1 meter and y equal to minus 1 meter. So acceleration at the point 1 comma minus 1 is equal to 5y minus 12j. That's all. So magnitude of the acceleration, root of 5 square plus 12 square, which is 13, because 5, 12, 13 is a triangular triplet, Pythagorean triplet. Okay, so 5 square plus 12 square is 13 under root, of course. Okay, so square root of 5 square plus 12 square is 160, the square root of 169, which is 13, and you know 5, 12, 13 form a Pythagorean triplet. That's all. Okay, so 13 should be the answer. Yes, good. That's how you can get the acceleration vectors directly. So 13 is the answer. Next, the potential function for a 2D incompressible flow field. Okay, so 2020 potential function for a 2D incompressible flow field is given as phi is equal to this magnitude of the velocity at the point 2 comma 1. Actually, come on, solve this. 2020. Okay, that's one of the easiest papers, in fact. 2020. Chalo, potential, like how mechanical came this year. The potential function for a 2D incompressible flow field is given by magnitude of the velocity at the point 2 comma 1. So how do you get the velocity? Gradient of phi. Okay, and if you take the gradient, dou phi by dou x of this 3x square by 3, so you have x square minus y square I cap, because if you differentiate with respect to x, this function gives you 3x square by 3, so x square minus y square I cap plus dou phi by dou y j cap. So dou phi by dou y is minus 2xy j cap, that's all. Okay, if you differentiate dou phi by dou x and dou phi by dou y, of course. So then the velocity at the point 2 comma 1. So if you put 2 comma 1, 4 minus 1 3 plus 2 comma 1 minus 4 j. So this gives you magnitude of velocity is root of 3 square plus 4 square. Okay, because if you have a function phi, you know how to calculate the gradient, that's all. Okay, it's like 1-2 steps to solve this. Okay, fine, it's good to see 5 in the chat box. See, when I'm teaching, if you feel like we are going little fast or low, you can tell me in the chat box. Okay, yes, anyone feeling fast, going fast? Honestly, अगर है तो बताइए, मैं definitely slow करता हूँ. Important topics in FM for XC, एक है कि जो वो viscosity का questions होता है ना, cases, shaft, sleeve, rotating, all these things. Second है कि वो जो types of fluids, non-Newtonian fluids वाला, ठीक है? Then manometers keep coming every time. Go slow. Okay, fine. ठीक है, I'll slightly slow down. Omkar, good now? Okay, and like manometers, then hydrostatic forces, especially the curved surfaces, like you have seen one pipe, this thing come frequently. Then in kinematics, especially like the differential analysis, if you see all the mathematical questions like divergence, curl, okay, incompressibility, continuity equations, these questions keep coming again and again. Then based on Bernoulli's equation, okay, and RTT questions come again. And in types of flow, in flow through pipes, they ask you about the plane Poiseuille or the quick flows, especially in XC, because flow through pipes is like common, we study. Then dimensional analysis, you'll get some good questions, especially like equating Reynolds number of both the model and the prototype. In these cases, you'll get a lot of questions. Okay, slow during concept time. Okay, okay, good. Chalo, let's continue. 17th question. 2011. Two tanks A and B with same height are filled with water till the top. The volume of tank A is 10 times the volume of tank B. What can you say about the pressure PA and PB at the bottom of the tanks A and B respectively with the same height are filled with water till the top? Tell me, what is this? You have two tanks, okay? Like in one tank has 10 times the bigger volume, but height of the tanks is same in both the cases. Then it should be C, obviously, right? So you can see if you have two tanks, both are of same height, this is actually called the hydrostatic paradox. This is 10 times that of the volume of tank B. So this is PB. Okay, the pressures PA and PB at the bottom of the tanks are same. So we know dou P by dou Z, or in static conditions, so this is fixed. The condition that this is what you need. Okay, hydrostatic paradox. Yeah, this time about the same question, the velocity is given, but same tanks with different fluids. Okay, anyway, so PA should be same as PB. The only one thing in this case is filled whatever till the top, and tops are open to the same atmosphere. Okay, that should be given anyway. So let's solve this. A manometer has come in an inverted manometer as shown in the figure. So question number 18, 2020 again. So in an inverted manometer as shown in the figure, pressure difference PB minus PA is 100 kilopascal. So here there is point A and here there is point B. So PA minus PB is 100 kilopascals. Use specific gravity of oil as 0.8, density of water is 1000, density of mercury 13,600, acceleration to gravity is 10, height of the water column H. So यहाँ जो water column है इसका height कितना है बस. Okay. Now if it is inverted, then you will take the topmost interface, correct? And the topmost interface is at this point. This is the topmost interface. Okay. Now, as per hydrostatic law, here if you call the pressure to be P1, and here if you call the pressure to be P2, okay. So if you start at this point A, so how many total questions are we going to solve? Even I don't know. Let me check once. Somewhere around 30 questions, I think. Yeah. Okay. I think we can solve. No issues. We'll cover a lot of nice things. Okay. Don't worry. Jumping method. I don't know what is this jumping method, but anyway, let's see. Let us travel along the hydrostatic interfaces. Okay. So if you have PA here, then by the time you reach from here to here, okay, you are moving in the upward direction. So the pressure at this point is PA minus rho water GH. Rho water GH. So at this point, again from here to here, you have this oil, and that's of 15 centimeters. So minus density of oil G into point, how much is that? 15 centimeters. Okay, so 0.15 meters. So that's the pressure at this point. Okay. Now what about the pressure here at this point? PB, and you have a total line of mercury till this point. Okay, that's the interface. So total mercury. So let's see. PB, this is 30, this is 15, and this is H, of course. So plus PB minus rho mercury G into 30 centimeters, 15 centimeters, 45 centimeters plus H, and H is also in centimeters, let's say. So H is in centimeters, let's say. So 45 plus H, so 0.01 into 45 plus H, where if you write this equation, H is in centimeters. Okay, H is in centimeters. Or you can also write this equation as 0.45 plus H, and then take H in meters. Okay, you can do any of these things. So let's do that way. Otherwise, H is in meters. Then directly 0.45 plus H. That's all. Yeah, otherwise, one more units conversion unnecessarily. Okay, so H is in meters now. Please do send this file in the group. Yeah, okay, I'll share this. Okay, so chalo, let's see now what they're asking you. PB minus PA is 100 kilopascals. Good. So PB minus PA is equal to rho Hg 0.45 plus H minus rho water into H minus rho oil into 0.15, this complete term multiplied with G actually. Okay, so this is the hydrostatic equation after this manometer balance. Now let's see. This PB minus PA is 100 kilopascals. So we'll write this as, this value is 10 to the power 5 pascals. This is 13,600. No idea about H. Water density is 1000. Oil density is how much? Oil is of specific gravity 0.8, so 800. And G का value कितना है? It's 10. Okay, so this is 10. Now everything is in SI units. H का value जो आता है वो है कि meters में. ठीक है. Now let's see. Only one equation, one unknown, that to linear equation. So let's solve. H is equal to, if you solve this equation, you will get the answer of H in meters. You can get that in centimeters. But let us solve carefully. Okay. So चलो यहाँ से start करेंगे. 1 0 gives this 10 power 4. Then 2 zeros in every value makes this 100. Okay. So 100 plus, so let's see, 100 plus 8 into 0.15, so 12, 8 into 0.15. Okay, so 1.2 obviously, so 101.2 minus 136 into 0.45 minus 136 into 0.45, so 40 is equal to 136 minus 10, 126 H, so divided by 126, 0.31746. That's all. Yeah, 31.7475. It's okay, good. 32 tak nahi jai. It didn't move up to 32. What is the value you are asking? Round off to 1 decimal place. Then 31.8 you can say. Because 7 is odd number, so you can make it even. So 31.8 centimeters. Okay. 31.7, 31.8, it's okay. They might have given some range because the rounding off is there. Okay. Is there a video of fluid kinematics taught by you on YouTube? It's there. Last year, 2024, fast track crash course. Can we write only 0.75 without writing? Yeah, you can write 31.75, but generally it's better to round off. Okay. Why? Because I'll show you one question today in maths when we are solving in the night. Okay, you will understand why. Okay, it's fine. Everyone, type in the chat box a simple manometer question. Okay, nothing complicated. Yeah. Okay. Chalo. So let's see. 2021 again NAT. For the configuration shown in the figure, oil of density 800 kg per meter cube lies above water of density 1000 kg per meter cube. Okay, so this is water and this is oil. Assuming hydrostatic conditions and acceleration due to gravity as 10, the length L, so this length L in meters if this angle is 30 of water in the inclined tube is dash. So again apply manometry. L is the full length, okay, the total length. So if you equate the pressure at this point and also at this point, so from, okay, so let's see. From manometry, here this is PATM and that's also PATM. So if you call this point A and this point as B, PA should be same as PB. So what is PA? P atmosphere plus this oil column of height 0.5. So density of the oil G into 0.5 plus you also have water column of 0.5 height. So these things is equal to, then definitely the pressure till this point. So PATM plus, now tell me one thing, this is total L. Can I write density of oil or density of water into G into L? Can I write like this? Can I write like this? There is a slant fluid column of length L, then the pressure difference between the fluid ends is OG into L is what I am telling. Is this okay? No, you should not write it, okay, because you'll see the dou p by dou z always gives the vertical separation of the points. Clear? So there should be sine theta. Okay, then you can cancel up this g from the remaining terms. What do they want? The length L. Okay, so L is equal to 1 by sine theta times, and if you cancel this OW, you'll have a OW here. So specific gravity of the oil into 0.5 specific gravity of the oil into 0.5 plus 0.5. That's all. Okay, correct now? This is what you have. So 0.5 times of 1 plus specific gravity of the oil by sine theta. That's all. Okay, so let's calculate. Put the values, and 1 by theta is 30, so sine 30. Specific gravity of the oil 0.8 anyway. So this gives you 0.9 into 2, 1.8. Okay, straightforward answer, 1.8. Okay, see, only till here it's fluid mechanics. Okay, here after a bit of simple maths to do the calculations. 1.8, it's in meters, so we can keep it in meters. Is it okay to skip extra portion of maths which is not in ME for XE? No, not okay, because in maths every time from these extra topics at least some 2-3 questions keep coming up. Okay, so you should be careful, especially the solutions of wave equations, heat equations. These things keep coming again and again. Okay, chalo, let's solve this question. 2012. Back at that time there are very good things. So a vessel containing water density 1000 kg per meter cube and oil of density 800 kg per meter cube pressurized by a gas of 2 bar. So because of this piston, this gas is pressurized to 2 bar. Okay, then you have some oil of height 1 meter, and then you have this water. Okay, assume that the gravitational acceleration is 10. The pressure exerted on the bottom wall inside the vessel is dash approximately. Okay, I think it's an easy question then, simple. So pressure in bar exerted on the bottom side wall inside the vessel. Okay, so what is the pressure here at this point? That's all. Okay, please list the extra topics of maths. Yeah, definitely today. Okay, we have 3 sessions from 7 to 10. So today, tomorrow, and today is Tuesday, no? So Tuesday, Wednesday, and Thursday. Okay, so whenever the topics I teach, I involve questions from, sorry, whenever I teach the questions, I'll involve questions from all the topics, and wherever the extra topics I'll teach you. Okay, don't worry. Clear? People know about my maths. Okay, you can ask them. So some of them I have already done it. Chalo. A vessel containing water, so what you should do? Pressure on the bottom wall, okay, inside the vessel. So at this point, so clearly you see it's 2 bar already. So you have oil plus water, so answer should be definitely more than 2. Okay, then 2.38 to 23.8 to 38 whatever. So PA is equal to 2 bar is 2 into 1 bar is 10 power 5 pascals plus oil. So density of oil G into 1 plus density of water G into 1 total 3 meters height water column. Okay, so this is 3 meters height water column actually. And then let's see, G is 10. Okay, so this is 10. Density of oil is 800 kg per meter cube, and this guy density of water is 1000. No, of course, yeah, this is 1000. So PA is equal to 2 into this is 8000. Okay, so 800 into 10, 8000. So 0.08 plus this is 30,000. So 0.3, this whole value into 10 power 5 pascals, and 10 power 5 pascals is 1 bar, so PA is 2.38 bars. Okay, so 2.38 bar, that's all. Okay, fine. Same question. Oh, sorry. So same question, but something else is changed. What is that? The gate is 1 meter wide. Okay, so still here the story is same. 2012 again. Back in those days there were these questions where you have the common data for 1-2 questions. Okay, the vessel containing water and oil, same story. The gate is 1 meter wide perpendicular to the plane of the paper. So basically this thickness into the paper is also 1 meter. The force exerted on the gate is approximately. So what should be the force exerted on the gate actually? So to calculate the force exerted on the gate, you should identify what is the pressure that's acting at this point, correct? Normally if you see the hydrostatic force acting on a plane surface, OF G H bar times A, this is what you have, okay, and this gives you the gauge pressure at the center of at the centroid location. So if you see this is half from here, okay, so you should look at the pressure acting at the centroid location at the centroidal depth multiplied with the area. So anyway this area is 1 unit because this height of the gate is 1, width of the gate into the plane of the paper is also 1. So basically you have to calculate the pressure at this point. So see how can you do this? So this is nothing but P at, let's call this G for example. So P at G. So pressure at the midpoint of that gate is going to be how much? 2 bar. Maybe I'll go for a new page. Two plus this oil. Oil has contributed to 0.08 plus now this total pressure is how much? Like density of the water into G into this is 1 plus half, so which is 3/2 by 10 power 5 into 10 power 5 pascals into area which is 1, that's all. Okay, so this gives the pressure calculation into 1 of course. Like you can see this is the pressure at the centroidal location in pascals. Okay, this is in pascals, so since I am taking 10 power 5 common from these two, from this also I should take out, so a division with 10 power 5. So clearly G is 10 and density of water is 1000, so it gives only 10 times here. So this gives you FH is equal to, they have want the answer in newtons. Okay, so in newtons, and you have the options. Okay, so if you simplify this, so 2 plus 0.08 plus 3/20, so this is 0.15 into 10 power 5 newtons to 0.08 plus 0.15, this is 2.23 into 10 power 5 newtons. That's all. Okay, in 2024 fluid mechanics question was very easy, but in 2025 is very hard or not. I don't know astrology, man. I know only some fluid mechanics and maths and thermo, that's all, and some heat transfer. Okay, like basically thermal subjects and maths is what I teach. Okay, no idea in astrology yet, but definitely next year I'll try to gain some knowledge and we'll try to predict the questions before, like all the babas do. Okay, better no, so that when I teach fluid mechanics even in comprehensive batches, then पूरा fluid mechanics पढ़ाने की ज़रूरत नहीं है. Okay, I'll tell you one thing. Many times students, यहाँ जो मेरा paid class का students है उन लोगों को पता है, I'll teach lot of stuff. Okay, normally if you see the class notes of my fluid mechanics, it will be very fat notes. All the people, okay, all the people who attend my this paid batch or the basically the comprehensive course batches, they know this. Okay, when I teach fluid mechanics, they'll get a very big notes. Okay, it's not like I stress the subject so much, but we cover a lot of things actually in that. Okay, so many times students ask me, sir, why are you teaching, is derivations important for gate? ऐसा कुछ questions आते हैं, ठीक है? I'm telling you, भाई साहब, like gate clear करने के लिए whatever the knowledge you have, okay, just you have to revise that knowledge and go for the exam, and it's very simple exam in fact. Okay, it's a very simple exam which is based on just testing levels of which is just like the testing formulas levels, conceptual understanding levels and all. Okay, but I'll tell you, after you clear the gate exam, okay, जब आप interview के लिए जाते हैं, okay, like मान लो कि BRC, ISRO, okay, recently मैं भी clear किया था ISRO, so ISRO, BRC. So when you go for these interviews, you should have full command. Okay, you'll ask me like, sir, what questions can come in gate? Okay, at least I'll try some astrology a bit using AI with astrology nowadays, and then I'll give some topics. But after you clear gate exam and if you go on to the dais of any of these interviews, ISRO का लेकिन BSRO का किसी भी interview पे अगर if you go, then can I do my astrology and can I predict what questions that guy is going to ask you? Can I do this? Obviously not. Okay, but we can do one thing in common is to learn the subject. अगर आपकी subject strong है तो then you need not worry about anything. Whoever gives the paper, whoever is in the interview, you know, there's plenty of confidence which you will have. Clear? I am fine. Others, thank you. Is the selection done of yours? What do you think? हो गया या नहीं? होएगा या नहीं? हुआ. Okay. Anyway. हो ही गया होगा. या वो तो हम डिसाइड करेंगे बाद में लेकिन पहले फ्लूइड मैकेनिक्स एक्सी मैथ्स इस पे थोड़ा सा फोकस करेंगे. ओके, एंड व्हाट सब्जेक्ट डू यू टीच? आई जनरली टीच 4 subjects for English batches normally. If you see, one is maths, complete maths I'll teach, then fluid mechanics I'll teach, the basic thermodynamics and applied thermodynamics. These 4 subjects I teach generally. मैंने काफ़ी बार संदीप सर से हीट ट्रांसफर भी मांगा था लेकिन उन्होंने मना किया था. ओके, बट इट्स ओके. So these are the 4 things which we teach. Clear? Anyway, so this is 2.23 into 10 power 5. Answer is there or not? It is there. Yeah. Okay. So chalo, let's go to next question. Some 21 questions we have solved. Good. In 1 hour 45 minutes. चलो let's see 2010 जब मैं 10th class में था उस टाइम पे. So anyway, let's see. 2 walls are holding back water. So one is this wall and one is this wall. Okay, are holding back water as shown in the figure. Good. The resisting moments per unit length of the walls at points P. P कहाँ है? Yeah, there is a P here. Sorry. Okay, तो यहाँ Q भी है. Then this is the point P and this is the point Q. Per unit length of the wall at points P and Q are MP and NQ. MQ. Denoting the specific weight of the water as gamma, the difference in the moments MQ minus MP. Okay, so what do we have? चलिए let's see. So this is, and this height is h. थोड़ा सा टाइपिंग का इश्यू, कोई दिक्कत नहीं, हमको पता है. So we have the free surface. ठीक है. So 2 walls are holding back this water as shown. The resisting moments per unit length of the wall at points P and Q are MP and MQ. Denote the specific weights. Okay, so let's see. पहला जो wall है ये ऐसे है. Then since it's a fixed wall, definitely it's like it is fixed. No, what they are telling are holding back water. So maybe some hinge. I think it should be fixed then in that case. Okay, so let's see. You have the moment, of course. So you have some moment and there is some hydrostatic force FH. Okay, and this point is P and let's say this distance is A for example. Okay, this distance is A and this height of the water column is how much? This height of the water column kitna hai? H. Okay, fine. height of the water column is h. So definitely p कहाँ है, यहाँ, ठीक है. अब देखिए, क्योंकि जब ppt में आया तब p was typed in almost like 1.2 mm micro channel diameter, okay, which I was not able to see in fact. Yeah, but this is p. Okay, chalo. Now let's see. So at equilibrium, like for example you take summation of moments about p has to be 0. Maybe you can take the anti-clock sense to be positive. So moment at p, because this is the external moment at p that we have, minus fh into a, or you can write fh into a. So this is mp value. Okay, so how do we get this mp value, fh and a values basically? Okay, so clearly, you know, if this is h, then the hydrostatic force acts at this line being h by 3, correct? Yes or no? Correct now? I h bar, which is h by 2, plus I xx. So if you take this value, so this is b, so b d cube by 12 into area into h bar. So this gives you h by 2 plus h by 6. ये कितना होगा? 3, 6. So 2h by 3 is the depth of center of pressure. So definitely from the base it's going to be h by 3. Okay, because generally I don't remember these values. Many times I don't remember, so that's the reason. So anyway, it's h by 3. So you can see A is h by 3. Good. ये तो बढ़िया बात है. Then what about fh? Density of water G into area. So what is the area? That's in contact, of course. Okay, so GA, A is h into width. So what is the width of the plates into the wall per unit length? Okay, so W or h into 1, of course. So G area into h bar. So for this, h bar is half of this h. So therefore the moment about the point P is equal to this guy, or gamma W, because O W into G is specific weight, gamma W into h square or h cube by 2 these are 6. Okay, so this is the moment about the point P, specific weight into h cube by 6. Okay, yeah, OG h cube by 6, or specific weight into h cube by 6. Now let's look at the second story. You have the gate, okay, so you have the gate and you have the hydrostatic force, obviously like this, normal, and this point is Q. So there is a resistance MQ at this point, and this is the free surface level. So this is some angle theta. Okay, and this length is not known, but what is known? Height h is known. Okay, so this is h. Good. So again, MQ is equal to, let's say if this length is B, for example, so MQ is going to be F H2, let's call it, into B. Of course, again you apply the moments and all, you would get this reactions. Okay, so summation of moments about Q dating anti-clock sense positive is 0. Okay, so let's say here it is. So F H2 कितना होगा? Rho F G into, so depth of centroid, correct? Rho F G into centroid depth. So centroid is somewhere here. Then what about this depth? Definitely h by 2, correct? Because whatever is the length of the plate, definitely centroid will be vertically at a depth of h by 2 from the free surface. So F G h bar into area. So what is the area of the plate? Now if this is h, like for example if this is h, then what is this length? H by sine theta, correct? H by sine theta into 1. So rho G h bar into area, that gives the values. Then what about B into B? So B कितना होगा? That's the crux question. Okay, so if you see this angle theta, theta का value कितना दिया था? 60 degrees. Okay, fine. So theta is 60. So theta is 60. Then let's calculate the depth of center of pressure, for example. So let's say somewhere here. Oh sorry, this is the center of pressure. So what should be this dimension from the top? Let us calculate this h bar. So h bar is equal to depth of centroid of the free surface, h by 2 plus Ixx moment of inertia. So again, if you take the plate to be something like this, if this is 1 meter, that's the length, okay, so that's the width perpendicular. So 1 into this length is h by sine theta, so b d cube by 12 into area into h bar. So this should be the h bar value, correct, the depth of centroid from the free surface. So you can see, so this is 6, then 1 h sine theta and h sine theta gets cancelled, and this h will cancel one more h. So h bar is h by 2 plus, okay, so h bar is h by 2 plus we have h by sine square theta. So h by sine square theta into 6 sine square theta, that's all, okay. So h by 2 plus h by h square by 6 sine square theta h, so h by 6 sine square theta, and sine square theta का value कितना है, sin theta is sin 60 root 3 by 2, so 3 by 4. So sin theta sine square theta is 3 by 4. So then in that case you have h bar is equal to h by 2 plus 2 table, and this is 3 table, so 9 by 2, so 2h by 9, that's the value, okay. So h times of 1 by 2 plus 2 by 9. Now that's the depth of this centroid, okay. So if that's the case, then obviously the slant would be by sine theta, so this divided by sine theta, so 2 by root 3. So b is equal to h by sine theta minus this length actually here. So b calculation is slightly lengthy, but it's okay, it's a inclined surface. So let's see once quickly. H bar is equal to this value. So what is this value? 1 by 2 plus 2 by 9, 2 by 9 plus 0.5, 0.72 h. H bar is equal to 0.7222 h, okay. So this is 0.7222 h. So if h bar is 0.722 h, which means this center of pressure, okay, Cp, let's write, this center of pressure is vertically at this much depth, of course, okay. But if this is the vertical depth, what would be the slant depth actually? So slant depth is how much? Or else better do one thing. So what is this part? Let's call it C, okay. So C is equal to 1 minus 0.722, 0.278 h. So if this height is 0.278 h, then the slant length would be divided with sine theta. So 0.278 divided by square root of 3 by 2, so 0.3207. So b value is 0.3207 h is the moment arm, of course. So that's all. That's just calculating the center of pressure using this expression, okay. Okay, now it's fine. Clear? Is this okay or no? Type it in the chat box. This is the value of B, of course. So mq का value कितना होगा? mp is equal to gamma w h cube by 6 minus, okay, so minus, I think they want us to keep this root 3 by 2s actually, okay. So they want voice issue. Everything is fine. Everything is fine, no? No? Sound problem still? अभी भी आ रहा है क्या? Okay, now it's okay. Is it okay now? Confirm the audio. It's okay now? Clear? Yes. Okay. So let's see this. Yes. So MQ. So first of all, MP is equal to gamma W h cube by 6. MQ. This is also going to be gamma W. This is gamma W into h cube by 2 times of sin theta. So 2 times of sin theta is root 3 0.3207 whatever. That's all. So therefore MQ would be high definitely. So MQ minus MP is dash. So MQ minus MP is gamma W h cube into 0.3207 by root 3 minus 1 by 6. That's all. So 0.3207 by square root of 3 minus 1/6. 0.0184. 0.0184. So let's see in the options which gives you the option of 0184. Okay. I think these options are not this question's options. They have just copy pasted these two options here. Can we quickly get this 2010 paper if you have? Because I think here 0.0184 is what you get. So 184 by 10,000 almost like. I think these two options are not edited. These two are from the previous question. Let me quickly open this 2000. Just a second. 2010. Okay. We have the papers, I think. No, we have only EC and ME. Just a second, guys. कुछ तो कुछ हो गया. Downloads. Yeah, downloading. Done. So then $2000 पेपर कितना है इसका 2010. Okay. कुछ विजिबल नहीं है इसमें, but it's okay. Fluid mechanics has started here. Yeah, here it is. Okay, so gamma h cube by 18 and gamma h cube by 2. I think gamma h cube by 18 would be the correct answer, because if you look at 1 by 18 value, 1 by 18, so 0.05. Oh, and what's the next one? Gamma h cube by 2, 2 gamma h cube by 3. Is it? Angle is 60. MQ minus MP. Guys, let's do this calculation once again if something is not very forward. Okay, so first of all, let's add these values. Gamma h cube by 18, gamma h cube by 18, and gamma h cube by 2. Okay. Okay, so let's quickly check this calculation once again if something can be done better. I'm erasing this part. Okay, so maybe we'll do this part once again so that if there is some issue anywhere we can figure it out easily. Okay, I'll also make this diagram once again. So clearly you have this phase surface, okay, and this angle you call it 60 degrees. Okay, so this is gamma h cube by 6, no issue, no? So f g h by 2 into h by 2, so this is the pressure into h into 1, so gamma w h cube by 2, this is 2, no, actually, into h by 3, yeah, this is h by 3, of course. So this gives you by 6, correct. Now coming here, okay, so because let's do it a bit carefully so that we don't make up any mess ups here. Okay, so this is the hydrostatic force Fq, let's say, for example. Okay, one thing is very clear, this full height is same, this is you know, no need to do all this stuff, let's clear this. So this is 60 degrees and this height is h, of course. Okay, so this height is h. So this is h. So you want this moment at this point q, about this point. Okay, so clearly fq into this length, let's call it b actually. Okay, so this length let's call it b, sin square theta आएगा sir h star. Okay, let's see, it's also for civil engineering, yeah, you can use this. Okay, because जो questions है वो फायदा होगा. So let's see, fq is equal to rho w g area. So what is the area of the plate? If this is h and this is 60, then this length would be h by sin 60. So 2h by root 3 into 1 into area of depth of centroid. Okay, so what would be this depth? So this depth would be definitely h by 2, undoubtedly. So h by 2. So 2 gets cancelled. So gamma w h square by square root of 3. This is okay. Now you should calculate what is b. So to calculate what is b, what we can do is, if this is h star, okay, if this is h star, for example, the depth of center of pressure, so b can be written as h minus h star divided by sin theta. So 2 by root 3 of h minus h star, that's the value. So how do you get this h star value? Let's see, h star is equal to h bar, so which is the depth of centroid is h by 2 plus ixx, moment of inertia about this axis. So this length is 1 meter and this slant length is h by sin theta. Correct? So b d cube by 12 into area. So 1 into h by sin theta into h bar. Okay, so we have h by 2. This is what you have. Okay, so let's simplify this carefully. So if you simplify h by sin theta, so you have sin square theta here and you have h square. If you cancel this h, you would have only h, then 2 cancel this 6 times. So h star value is going to be h by 2 plus h by sin square 6 sin square theta. So h divided by 6 sin square theta. So h by 6 into sin square theta. So which is 3 by 4. Okay, so h by 6 into 3 by 4. Then let's see 2 table and this is 3 times. Okay, so 2h by 9. So h star value in that case is equal to h by 2 plus h by 9, 2h by 9. So this gives you 9 plus 4, 13h by 18. Okay, so this is 13h by 18. So therefore this value b 2 by root 3 into h minus h star, correct? So h minus h star value is this 13h by 18. So 2 by root 3 into 5h upon 18. So this is 9. So b value is 5h by 9 square root of 3. That's what. Okay, so 5h into 9 root 3. So now if you calculate mq, moment about the q is equal to gamma w h square by root 3 into this term. So 5h by 9 root 3. So this is 5 times gamma w h cube by 27. Okay, so this is the moment which is acting at the point q, of course. So mq is 5 gamma w h cube by 27. So if you calculate mq minus mp, so 5 by 27 minus this is 1 by 6 times gamma h cube. Okay, so you can see like this is 5 by 27 minus 1 by 6, of course. So 30 minus 27, 3 by 27 into 6 times gamma h cube, correct? This is the value you get, 30 minus 27 by 6 into 27. So clearly this is 2 gamma w h cube by 54 is the difference that you are getting. So it's 11 by 18, sir. Which one? Which is 11 by 18? This one? 9 plus 4, no? H star. You can see h by 2 plus 2h by 9 is 9 plus 4, 13 by 2 9s are 18. It's okay? Like on the top there are any extra moments? Nothing, no? That's just land gate and you have the fluid acting, that's all. Okay, then it's correct. Any questions in this? It's h by 2 plus h by 9. Is it? It's not 2h by 9? There's a 2 here, na, in the denominator. H by 2 plus h by 6 sine square theta. This 6 is here, sine square theta. So root 3 by 2 whole square is 3 by 4. So 4 2 table twice, 2 table thrice, 9 by 2. So 2h by 9. Yeah, 2h by 9. It's okay. We made one mistake. Can anyone tell me what is that mistake? Yes, exactly. We forgot to do sine square theta multiplication here. That's what. Then this becomes only h by 6. Because h star we are missing that sine square theta. Got it? Understood, no? So because of that sine square theta, then this sine square theta and sine square theta gets cancelled. You have only 6. H by 2 plus h by 6, which is h by 3. Correct, no? So 2h by 3. So this is 2h by 3. The depth of center of pressure is 2h by 3. So if you write now 2h by 3 here, so this is h by 3. So 2 by 3 into this. So 2h by 3/3. So this is 2. Okay. So here you place 2h by 3/3. Then you have this is 2 and this constant keeps changing. So this is 2, then 2 gamma w h cube by 3 is a 9. Okay. So this is 2 and this is 9. So this is 2 and this would be 9. Then this is 2 by 9 minus 1 by 6. So if you take LCM, 12 minus 9, 3 by 9 into 6 gamma h cube. Okay, that's the difference. We missed that sine square theta, but definitely this formula has sine square theta. Yeah. Okay. So because of that, we got an issue. Okay. Clear? And one more important conceptual point here: if the vertical separation is same, then the depth of center of pressure and depth of centroid is also same. Okay. Like in these two cases, if you see one thing carefully, here the depth of the centroid is h by 2. Here also the depth of centroid is h by 2. Here depth of center of pressure is 2h by 3. Here, even after doing the full calculation, you figured out this is again 2h by 3. Okay, that's the learning from this question. Clear? Even if the plate is inclined, then since the total fluid column is same, okay, h is not defined with respect to plate length, h is defined with respect to the vertical fluid column. So definitely, as this h is same, even here you would get the h by 3. Okay, so gamma w h cube by 18, it should be somewhere. Option C is the correct answer. Okay, so we should make sure we don't make this simple silly mistakes. Okay, because I myself have derived this so many times in class. Okay, but when you are solving, sometimes you go out of the zone and things get distracted. You should be careful. Okay, chalo, let's see. Let's go to the next question. Anyway, these two options, I think the DTP has forgot to edit it, but it's okay. Then no need of this slide. Okay. Fine. So let's solve this question. 23, 2010 again. A differential U-tube manometer with mercury as manometric fluid is used to measure the pressure between two sections at P and Q in a horizontal pipe. If the difference in mercury levels in two limbs is 0.75 meters, okay, so this difference in the mercury limbs is 0.75 meters. The difference in pressure between sections P and Q. A simple question. Come on, do this. So let's say here the pressure is P and here the pressure is PQ, for example. Okay, then from manometry. So this is an inclined tube manometer. Okay, so let's see. If you take this line like this here, okay, let's say this is the interface. So obviously pressure at this point is same as the pressure at this point because this is a static fluid, and at here is same as the pressure here, and you know the difference also here. Okay, so let's go till the middle here because it's a straight manometer. Okay, and the pressure at here and here would also be same. Okay, 0.75. So now let's see, you start at PP and let's define this length as x, for example. Okay, for the time being you define this as x, then this is also x, of course. So from manometry you start here PP minus, you're moving top, so this is the water, x plus 0.75. So water G x plus 0.75. So you reach this point. So from here to here again the pressure is same. So from here to this point you again come back 0.75. So plus rho water G 0.75. That's all. Okay. So we have reached this pressure. Let's call this point A, for example, and this is point B. So PA is equal to PB. So this is the expression for PA actually. Okay. Now coming to PB, the pressure at this point, so PQ minus density of water again, x plus 0.75. So use this point. So here and here again the pressures are same, but this is mercury, so 0.75 downwards plus rho mercury G 0.75. Okay, so this is the static pressure balance equation. So then clearly you can see this term and this term cancels out. So normally in a pipe flow you will experience the pressure drop in that direction since there is no elements like pump or anything here. So the difference in the pressure PP minus PQ, .75, okay, minus PQ. So density of mercury, what is the value of that? We have density of mercury, okay, nothing is given, so let's take the standard values. 13,600 minus 1000 into 9.81 into 0.75. So this is in pascals, okay, because you put everything in SI units and the answer they want is in kilopascals, okay. So just pick up a calculator and punch some keys. Then 12,600 into 9.81 into 0.75, 92704. Okay, so that's kilopascals, right? So PP okay, so 92.704. Anyway, options are given. Let's see. 92.70. Okay, maybe some standard values are not taken back in 2010 I think. So 94 is the best possible option. You can go with this option. Okay, because they haven't given the densities. Fine. 94.275 is the actual answer. Okay, 94.275 is given, so that's the closest, so you can tick. So let's solve 2009, some 24th question. What's the time by the way? 4:20. Okay, we have time, no issues. So consider incompressible flow through a 2D open channel like this at a certain section AA. So here the velocity profile is parabolic. Neglecting air resistance at the free surface, find the volume flow rate by unit width of the channel. Okay, so what is the unit width of the channel, for example? And here this maximum velocity is 10 meters per second. Okay, and here it is 0 because of no slip. So they want the total volume flow rate by unit width of the channel. So let's see, some options are given. Let's work out. Volume flow rate is equal to integral rho V, density is not there, okay, because volume flow rate V times dA. Okay, so V times dA because the area is perpendicular to this section and width of the channel is 1 unit. So this dA can be written as, if you take a small elemental length of height dy, then this dA can be written as dy into width, and this width is 1 unit again. So the total discharge flowing is V times dy. Okay, but and y is changing from 0 to 2 meters. Okay, y is changing from 0 to 2, but the question is you don't know what is velocity, right? You don't know what is velocity. So how do you get the velocity? So here it's given the velocity profile is parabolic in nature. So let V is equal to A plus By plus Cy square. You know this. Okay, so this is the most general velocity profile in parabolic sense. So now to get this you have 3 constants, you need 3 boundary conditions. So what are the 3 boundary conditions? First I'll tell one, which is very easy. So to solve this we need boundary conditions. So the first one, at y is equal to 0. Okay, you see y is being, let's say y from this direction 0 and y. So at y equal to 0, because of no slip, v equal to 0. So I have told one boundary condition. 2. Now, can anyone of you tell me another thing? This is a height of 2 meters. This is height of 2 meters. So, can someone tell me any other boundary condition? Y equal to 2, V equal to 10. Fantastic. Okay, you guys are smart. At y equal to 2 meters, V is equal to 10 meters per second. So if I substitute these two, first if you put 0, I'll get A equal to 0. Okay. So this gives you 10 equal to 2B plus 4C. Okay. So this value is figured out, A is 0. But to get C, you need one more boundary condition. So can someone tell me any other boundary condition? Any other condition? I need 3. Okay. 2 पता चल गया. So तीसरा क्या होगा? Just a second, guys. This pop-up comes every time. Okay. So what we are doing? Yeah, this question. So tell me, what's the third boundary condition? Sorry. At y equal to 2, du by dy is 0. Fantastic. So at y is equal to 2 meters, dv by dy should be 0. Why? Because you see here the velocity profile comes from 0 to some starting value, and this keeps going. If you keep drawing a tangent, the tangent becomes parallel to y-axis. So at y equal to 2, the tangent to the velocity profile comes exactly parallel to the y-axis. Okay, so then you don't have any slope. Okay, let's say if I tell you cubic, let's say you have a plus by plus cy square plus dy cube. If you want one more, then what will you do? Luckily in this question it's given quadratic, so you know 3 conditions. No slip from 2, no slip at y equal to 0, then at y equal to 2 velocity is 10, you know that. At y equal to 2 du by dy is equal to 0. If I ask you the 4th boundary condition, let's say, then how would you get that 4th condition? Let's say when I'm doing boundary layers, okay, I need more accuracy, so I'm going, so normally if you see the boundary layers, this is some flow, like some velocity profile in a boundary layer. So if you see u by u infinity per y by delta, if I call it eta, this is some function of eta, you know this, okay. And when you have no idea, the best approximation is the series solutions. So this can be written as a plus b eta plus c eta square plus d eta cube and blah blah, lot of, okay. And depending on the number of terms you cut, you will have the accuracy, okay. Nidhi has answered. At y equal to du by dy is 0. That's the 3rd condition. Okay. Yeah, correct. D square u by dy square. Fantastic. At y equal to 0, the du by dy value is the maximum out of all the locations because the tangent is perfectly perpendicular. So d square u by dy square is equal to 0. But you should go in a sequence. Okay. First, no slip. Then the boundary condition at y equal to 2, velocity is equal to 10. Then at y equal to 2, the first derivative, because the order of derivatives could keep increasing when you are writing the boundary conditions. Okay. So these two are the 0th order boundary conditions, first order boundary condition, second order boundary conditions. Okay. So this is how you keep getting the constants. Okay. Anyway, this is a different story for some time. Chalo. Now let's see in this question. So if you differentiate b plus 2cy, so 4c, correct? No? 2cy, and if you put y is equal to 2, 2cy, so if you put y equal to 2, you have 4c. So this gives you b equal to minus 4c. So this gives you 10 is equal to minus 8c plus 4c. So minus 4c. So c equal to minus 5 by 2. Correct? No? c equal to minus 5 by 2. So b is equal to minus 4 times minus 5 by 2. So this is plus 10. So b equal to 10. This is the conditions we can solve. Just solve these linear equations once again. A equal to 0, obvious. 2b plus 4c is equal to 10. Okay. At y equal to 2, b plus 2cy. So 4c is equal to 0. So b equal to minus 4c. Minus 8c plus 4c is 10. So minus 4c is 10. That's minus 5 by 2. minus 5 by 2 minus minus gets cancelled. This is 10. Okay, so you have the velocity profile. So therefore v is equal to by. So by plus c, so which is c is minus 5 by 2 y square. So this is the velocity profile. Now you can get the discharge. Q dot is equal to y equal to 0 to y equal to 2, this v dy. Okay, so just integrate this. So this gives you, correct now? So this should be the answer. Okay, let's see if we have an option with that. 16.67, no, 10, 20, 13.33, but how come? 50 by 3 is how much? 16 3s are 48, no? Perform the integration once again. There's a mistake here. So if you see this integration, 5 by 6 into 2 cube is 8 actually here. Okay, so this is 3, this is 4. So 1 minus 1 by 3. So 2 by 3 times 20. So 40 divided by 3, 13.33. Yeah, this is the integration. Okay, yeah, because you can see y cube, so 2 cube is 8. That's how we have 8 here. Okay, yeah, 13.33 is the correct answer in this case. You see, system of linear equation solving for ABC constant, then performing integration. So 1.33 meter, 13.33 meter cube per second. So since the time is a bit short, maybe last half an hour, I'll solve questions of potential flows. Okay, because other questions like Bernoulli's equation or this RTT, these things are quite common questions. So let's solve this. Okay, solution. Velocity field of a 2D steady flow is given by so you want stream function, a streamline of the flow. Okay, so how do you get the streamline? It's a 2D flow. So let's see. For dx by u is equal to dy by v for velocity is equal to ui plus vj, correct? So let's substitute dx by this is equal to dy by minus 2cxy. This minus sign you should take, okay, because when you define the velocity vector, it's a plus sign after ui plus vj. Okay, but now you have di by this, so cc gets cancelled. So if you see, minus 2xy dx is equal to x square dy minus y square dy. Okay, let's do something, some jugaad. So you bring this y square dy here, then y square dy is equal to x square dy. If this goes here, of course, see, ultimately you will be ending up with this differential equation. Dy by dx is equal to minus 2xy by x square minus y square. Okay, so we can solve this equation. No, it's a 1D homogeneous equation. I mean the first order homogeneous equation. Yes, so you take y equal to vx, that's the classical procedure, you solve. But since the terms appeared slightly catchy here, so if you bring it here, you'll get 2x into y dy, correct? This is dx, or y into 2x dx. That's all. It's a first order differential equation of homogeneous form, correct? So you put y equal to vx, you can solve this equation. But rather than doing all this business, you can see x square dy, and this can be written as derivative of x square. So this final equation is nothing but y square dy is equal to derivative of x square y. That's all. Okay, so that you can integrate. So for steady state, what is entropy generation? It depends on the you know, it depends on the type of process. Right? Anyway, I'll write one equation. Let's see. So if you solve this, you would get y cube by 3 minus x square y is equal to some constant. That's all. So the stream function is given by, this should be constant. Okay, or x square y minus y cube by 3. Anyway, so y cube by 3 minus, this is wrong, it's not y square, not xy square, this is wrong, and this is the correct option. Okay, see, because if this is a constant, then the minus n of that can also be constant. Entropy generation is positive or can be 0. Yeah, because if you see, normally if you take the process, okay, so you're talking about the steady state process. Okay, so let's see, cyclic integral del q by t across the boundary plus s dot generation is equal to d entropy of the control volume by dt. Okay, and this can be because of either mass or heat exchange. So or else let me write it as okay, del q by t plus one more term, summation of m dot in s in minus let me add the full equation maybe, so that you would be happily enjoying the things. Okay, now this inlets and outlets can be because of two reasons. One is due to the mass exchange across the boundary, and one is one is because of the heat exchange. Okay, so across the complete boundary, the heat exchange, so this is equal to dt. Now when you come up with steady state, only this term is 0. Okay, not this term. Got it? And generation is here. Inlet minus outlet is because of two reasons. One is because of the mass and one is because of the heat exchange. Okay, so because of the mass exchange, this is the term which takes care, and because of the heat exchange, at every point in the boundary, if there is some heat exchange that's happening at a temperature T at that particular point, then integration of del q by T gives you the total entropy change because of the heat interaction. The summation of all these guys is equal to the change in the entropy of the control volume, and if you are operating your system at steady state, your control volume at steady state, this term would be 0, and you cannot decide on this. Okay, if the process is happening irreversibly and at steady state, then this term is also 0, otherwise you cannot decide. Okay, like for example, you take a turbine, okay, an insulated turbine, then in an insulated turbine operating at steady state, adiabatic, closely insulated, then this del q is 0 across any point in the boundary if you insulate the turbine, and if there is a reversible expansion, reversible, so this is 0, and steady state, so m dot in is same as m dot out. That's how you have s in is equal to s out for turbines. Okay, otherwise s in is equal to s out. Let's say if they give you reversible but there is some heat loss, then one of these terms will come into the picture. Okay, so this is the entropy balance for the control volumes, and we'll make the terms 0 depending on the physics which is going there. Like this is the case for a steady state reversible expansion in a turbine. You will see inlet to the turbine and outlet of the turbine, and you will see in a Rankine cycle you put a vertical line for the expansion, like the constant entropy line. Okay, clear? Siddhartha? Is this okay? Anyway, we have slightly moved off the track, but is this clear to all of you? So this is the entropy balance, general entropy balance. Okay, and if you are talking about the closed systems, okay, if you talk about the closed systems, like let's say you have a box into which some heat is exchanged, these things, then these two terms will go out because there is no mass exchange. Okay, so these two terms won't be there. That's when you get, so this is for open systems where there is mass, heat exchange, everything. So for closed systems, the mass terms will go. So therefore you have cyclic integral over the boundary del Q by T plus entropy generation is equal to delta S. That's all. Okay, if it's a reversible process, this Sgen is 0. Okay, so delta S is equal to integral del Q by T is the case. And if you have a constant temperature, like you see in case of thermal reservoirs, okay, where in Carnot cycles, wherever, then this T is constant, it comes out of the boundary. So integration of small amount of heats, so summation of all the heats, that gives you delta S is equal to delta Q by T actually. Okay, or Q by T, whatever the notations you use, Q by T. Clear? This is the equation which talks about all the entropy questions. Each and every entropy question can be solved using this equation. You can see now, this is generalized. If it's a closed system, these two won't come into the picture. If it's insulated, then this don't come into the picture. So likewise. Okay. So anyway, this is the psi, so which is in option D, of course. Okay. Chalo, let's solve this. 2023. An inviscid steady incompressible flow is formed by combining a uniform flow with velocity u infinity and a clockwise vertex of strength k at the origin. So vertex has a strength of k, and that vertex is at this point origin. Okay, circulation or basically strength of the vertex. Velocity potential function phi for the combined flow in polar coordinates r comma theta. So let's see, you have a flow. The flow is combination of a uniform flow plus a vertex, a clockwise vertex, okay. So for work done, P1 V1 minus P2 V2 by n minus 1 can be used for quasi-static and sudden expansion processes. Only for quasi-static. Okay, for sudden expansions you don't know what is the intermediate states. Okay, like for example, let's say your piston is coming here and quasi-statically moving, then you know all these states. Okay, so you know that this is some PV power n equal to constant, whatever the value of n is, you know. But let's say you know this state and you know this state, but you don't know what is the path connecting, then obviously you cannot get the area onto the volume axis. Correct now? For polytopic you can use, yeah, for polytopic process you can use, but not for non-quasi-statics. Okay, means if there is some sudden rapid movement of the piston, then you cannot use these expressions. Okay, basically if I want to give you some small insight, I can give you, see, this is in downloads. When did I teach you thermodynamics? Anyone? Indu, Mahavir? I've taught you thermodynamics, no, recently, sometime back before fluids. This is ATD, so somewhere in August, I think. No, it's around May, I think, before maths. Yeah, I got the pages, I think. Okay, so here you see work chapter, concept of work. Maybe in the next notes. So if you see, yeah, here, okay, so this slide you can see, so some maths integrations, whatever we are teaching, this is the process actually. Okay, for linear spring, whatever you see many times. Okay, if you have a spring connected on the top of the piston, all this stuff. So you can see in piston displacement work, always we write this W is equal to integral starting of May, somewhere. So W is equal to integral PdV. Okay, we write when you integrate P is the pressure of the gas. Okay, this P is pressure of the gas is valid only when there is equilibrium, like there is quasi-static movement, and at every state you have an equilibrium, intermediate equilibrium during the movement of the piston. Okay, like for example, you see this is P external force and this is the P pressure of the gas. Okay, and you have a piston. Only when the piston is moving quasi-statically, these two things will become equal. Okay, and that's how your definition of this P gas is equal to P external. And if you calculate the piston displacement work, always this is the resisting pressure, means whatever is the external pressure you have into dV. Like for example, if you have a piston gas and if you have a vacuum here, okay, and if you leave the piston, then there is no work because there is no restriction on the piston. Clear? Your work should be always against some restriction. But here in this case, if you have vacuum and if this cylinder just expand, then there is no work because P resistance is 0 actually. So when you move in a sudden process like this, it depends on what is the P external here. Okay, but not on the pressure of the gas because the state of expansion is not quasi-static. Clear? And obviously if you are moving quasi-statically, then this pressure and this outside pressure becomes equal, because for thermodynamic equilibrium you should have mechanical, chemical, thermal, and also what is the other one? Mechanical, thermal, chemical equilibrium, and phase equilibrium. We should have these things. Okay, chalo. Anyway, so let's see. So I have given you some basic functions. So for this, the potential function. Okay, so if you see the velocity, if you see the potential function, complex potential function for this flow, this is the complex potential function. Okay, so let's see, this flow is in the x direction uniformly, so u infinity into z plus this is a clockwise vertex. So normally the velocity potential, the complex potential function for the clockwise vertex is plus I circulation by 2 pi ln z, correct? So I have given you a list of potential functions, the complex potential functions for basic flows like uniform flow, then vertex, then circulation of a vertex, okay, source, sink, for all these things, or flow in a sector. I have given you this basic complex potential functions. So if you simplify this, f of z is equal to, now what do you want? You want the velocity potential function phi. Okay, so let's simplify this. U infinity r e power I theta, so cos theta minus I sin theta plus ik upon 2 pi into ln z, so ln r plus I theta, that's all. And you know this complex potential function is nothing but phi plus I into psi, so we should look for the real part of this complex function, that's all. Okay, so if you look for the real part, u infinity into r cos theta, then plus I into I minus, so minus k theta upon 2 pi plus I into k by 2 pi ln r minus u infinity r sin theta. So this is the splitting, you can do it. So clearly now this is the velocity potential function and this is the stream function, that's all. Okay, so you should have something like this: u infinity r cos theta, u infinity r cos theta minus k theta by 2 pi, so minus k theta by 2 pi it's a clockwise vertex, right? So definitely u infinity into r cos theta, normal function is f of z is equal to minus I circulation by 2 pi ln z, but this is for the anti-clockwise vertex. Okay, and you have the clockwise vertex, so u infinity r cos theta, there should be a minus, no? It's a clockwise vertex, is it? Clockwise vertex, so plus ik, why 1 minus sign is coming difference? Clockwise vertex, normally we have the, for the anti-clockwise sense the circulation is positive, So for clockwise sense, circulation is negative generally. So minus I of this negative sign becomes plus, correct? So k by 2 pi ln z, 1 minus sign is these options are correct. 2023 k theta by 2 pi minus u infinity r cos theta. Let me go to fluid mechanics notes once. Maybe I am getting confused with sign conventions. So just a second. Potential flows. It's a clockwise vertex. This is doublet. Yeah. So vertex flows minus I circulation by 2 pi. This is the strength of the vertex, of course. So minus k theta by 2 pi plus u infinity r cos theta. Like if you take velocity at this point, let's say, for example here, the flow is coming in this way, and at this point, if its velocity is here, r is positive, theta is negative. So guys, I think there is some small issue with this. Okay, theta is taken anti-clockwise now, sir. Is it? Yeah, theta is taken anti-clockwise. Okay, so you're right, correct. So then this becomes theta is being measured in the anti-clock sense. 2023 k theta by 2 pi minus u infinity r cos theta. Let's say if you take theta in this zone, then obviously here if the fluid velocity is something like this tangentially, or you take fluid velocity is tangentially, it has positive x component and both keep add up. So similarly here if you take, it's negative in the fourth here, in the second it is positive, correct. Then it should be plus. Option B should be the correct answer, no? In that case. It should be u infinity r cos theta minus k theta by 2 pi, definitely. Because this circulation, this vertex is in clockwise sense. Okay. This vertex is basically in the clockwise sense, of course. So because of which you have k by 2 pi ln z ln r plus I theta, correct. Log of r into e power h is ln r plus I theta, correct. So which gives you minus plus I into I is minus k theta by 2 pi. Just a second, guys. I think you have some small issue. University study incompressible flow, of course, by combining a uniform flow with velocity u infinity and a clockwise vertex of strength k. So then theta is taken as minus theta, then definitely this should be the correct answer. Okay. Clockwise. So then it should be plus. Okay. So option B should be the correct answer then. Yeah, because theta is being in the general coordinate system, we take theta in the anti-clock sense, but here since the vertex is theta, maybe they might not have defined here, but that's the ideal thing. Okay. Ln z expansion samajhna aaya. Okay, I'll do it. So if in NAT I am getting a negative value, then we'll put positive or negative integer. You should, if you are getting negative, you enter negative. Okay, but in the question, if they mention enter the magnitude of the value, then you should enter positive value. Okay, clear? So ln z expansion, if you see ln z r into e power I theta, so ln r plus ln e power I theta, so ln r plus I theta times ln e, so ln e is 1, so ln r plus I theta, that's what. Okay, can you get this? So basically whenever you have a uniform flow, for the uniform flow this is the complex potential function. Okay, and for a vertex flow you have plus I times k by 2 pi ln z actually here. Okay. Yeah, so if you see ik by 2 pi ln z, then f of z is equal to this z can be written as r into e power theta, so r times of cos theta minus I sin cos theta. Just a second guys, I think it should be plus, no? So cos theta plus I sin theta, because r cos theta plus ik by 2 pi into ln r plus I theta actually. So then you have u infinity r cos theta, if you take the real part, u infinity r cos theta plus ik by 2 pi into I theta, so I into I is minus 1, but here since the vertex is in the clockwise sense, so we have taken theta to be a minus theta, so u r cos theta plus k theta by 2 pi is what you are getting. Okay, plus I sin theta, yeah, this should be plus I sin theta. Okay, that's the steam function actually. Okay, yeah, that's the correct answer then. Chalo, let's go to next question. 2022 again, 31st question mentioned in the PPT. A 2D flow field is described by a combination of a source strength at m and uniform flow u in the positive x direction, such that the velocity potential field is given by phi is equal to ux plus m by 2 pi ln root of x square plus y square. The stagnation streamline, so this is a stagnation streamline. Find the distance a dash. So what should be this distance? Anyone? We have done this so many times. So normally if you see for this is the normal Rankine half body. Rankine half body. Okay, so if this is Rankine half body, you can see phi is given by this. So in fact this f of z is equal to combination of a uniform flow, which is uz, u into x is the real part, plus m by 2 pi ln z, of course, for a source. So this is for your uniform flow and this is for your source. Okay, so you want the steam function. Let's see, ux plus m by 2 pi ln r or ln root of x square plus y square, whatever. So this is the real part, plus I times of u into y plus m by 2 pi times theta, m theta by 2 pi. That's all. Okay, so this is the streamline. M by 2 pi u is not that. M by 2 pi u is this distance, stagnation distance. This is m by 2 pi u. Okay, not this. So the streamline. So you can clearly see now, this is the equipotential function or the potential functions, and this is the stream functions, of course. Okay, so instead of theta you can write tan inverse of y by x. Okay, so psi of x comma y is equal to uy plus m by 2 pi tan inverse y by x. So along a stagnation streamline, this psi has to be 0. So if psi is 0 in the stagnation streamline at x is equal to 0, because you can see this is the point origin, so at x is equal to 0, if you put x is equal to 0, then this value becomes pi by 2 and y becomes uy plus m by 2 pi into pi by 2 is equal to 0. So this y coordinate is m by 4u, which means this height is m by 4u. So a dash is total double of this m by 2. Okay, so that's the correct answer. And you see this is m by 2u. When the body becomes saturated, the maximum half width is exactly this length. We have seen all these results. You remember in classes and all, we have seen all of these results actually. Like you see, Rankine half body, this is the vertex which we are talking, circulations, everything. So this is the Rankine half body, which we are uniform flow plus this source of 10 m. So you figure the half width, this is m by 4u. So if this is m by 4u, then BC is m by 2u. That's what. Okay. So we have done all this stuff in the class. Why is not coming? Okay. It's okay now? Is this okay? Can you hear me now? Can you hear me? Okay now? Okay. So did you understand this question? How it can be done? That were not in ME, and from where can we cover those? Basically I have taught them in the fast track last year. You can just go through them quickly. Okay, like last year after mechanical exam got happened, I have taken some sessions for extra topics of 𝐂𝐸 in maths, fluid mechanics. Okay, on the same channel you can find. So just have a vision to them, it's better. Okay, so this is m by 2u, because you can see this is the full length, a dash is exactly double. Let's see, in a steady state 2014, in a steady state 2D potential flow field due to a point source, so f of z is equal to m by 2 pi ln z, let's say ln z. The acceleration of the particle at a distance r is dash. Okay, so what is the acceleration of a particle at a distance r? So if you see, f dash of z is m by 2 pi, differentiation of ln z is 1 by z, so m by 2 pi r into e power minus I theta, correct? So if you see, in potential flows, the velocity f dash of z, we write it as u r minus I times u theta into e power minus I theta. So clearly this is the full expression that you get, which means in a vertex, in a flow with source, therefore the radial component of velocity is m by 2 pi r, and obviously it's a source. You can see there is no u theta. If you compare these two, u theta is 0, and clearly we know in a source flow there is no angular velocity. Okay, you have only the radial component. So acceleration in radial components is dou u r by dou theta, or first let me write these forms: d u r by dt minus u theta square by r, a theta du theta by dt plus u r u theta by r. Okay, so these are the two expressions, and az is duz by dz. So if you expand this, that's all. Okay, no z component. So anyway, this u theta is 0 and this u theta is also 0. So steady flow, this u theta is 0. So therefore you only have minus u theta square by r, and this u theta square is 0 because there is no u theta. So acceleration in the radial direction is u r dou u r by dou r, m by 2 pi r into the derivative of this minus m by 2 pi r square. So this tells you a r is proportional to r power minus 3. Okay, so that's what r power minus 3 acceleration is proportional to r power minus 3 actually. Okay, at critical point all substances have same latent heat of vaporization. Yeah, it is 0. Okay, because you cannot clearly distinguish between liquid and vapor phases at that point, at the critical point. Okay, fine. So there are some 2-3 more questions which we can solve maybe later. So today again at 7 PM on the same channel we have maths PYQs. Okay, so we'll solve all the maths PYQs, which are like, you'll see good questions, you'll enjoy a lot, because I think many of you might not have seen me teaching maths, so we can have some fun. Okay, so this is at 7 PM. Okay, so we'll meet for maths. Mahavision 2024, you covered these topics, yeah. So for maths there is a bit of extra syllabus, yes, we will figure it out. Okay, we'll solve, no issues. And you'll see majorly जब आप XC का पेपर्स देखते हैं उस टाइम पे एक फीलिंग आता है कि XC में थोड़ा सा टफ क्वेश्चंस आ रहे हैं, ठीक है, बट इट्स ओके, नो इश्यूज, विल डील विथ ऑल दोस क्वेश्चंस. मतलब कौन सा जो टॉपिक्स इंपॉर्टेंट होता है, ओके, जहाँ से मतलब जो क्वेश्चंस स्टूडेंट्स डिस्कम्फर्ट फील होता है, सो विल लुक एट ऑल दीज थिंग्स. क्लियर? So 7 PM today, same channel, so we'll start maths lecture 1. Okay, so thank you. Then I think we have solved almost some 25-26 questions, I think, but we got some good idea. So thank you. Then we'll meet at 7 PM, 2 hours after. Okay, thank you. Did you all enjoy the session? Liked it? Okay, so thank you, thanks for some heart symbols flowing, but anyway, so we'll meet at again 7 PM. Okay, thank you all, take care. So we have seen some fluid mechanics, we'll shift to maths after some time. Chalo, don't miss maths, okay, it's important. Bye, take care.